Hasda. Hello. Hey, Ganeshan. Oh God. Whatever it is. So bad. They get me back. అదొకటి
డబల్ సైడ్ టేప్ అంటే వాళ్ళు డబల్ సైడ్
ఆహా ఇది ఉందా లేదా అసలు
Go, I'm telling damn sure in exam also you hold your
Please settle down.
ఏ
I'm today taking
వాట్ ఐ షుడ్
nothing. Anyhow, nothing work is there today. No work is there today. You know.
ఏమో తేడా కొట్టదా నీకు ఉంది కన్ను అప్పలేదు
Someone tell me no, they right? Right? Yeah.
You got a picture I think.
No.
I section. A section. AC are you in A section? Hello, I thought are you in my section?
ಅಯ್ಯೋ ನೀನು ಬರ್ಲಿ ಫೋಟೋ ಒಂದು ನಿಮಿಷ
Getting so much fun.
Thanks, mom.
ಏಟ್ ಅಪ್ ಮಾಡೋದು ಯಾರು
Lunch break. ಆಯ್ತು ಟೀ ಬ್ರೇಕ್ ಕೊಡ್ತಾರಲ್ಲ ಅವಾಗ ಅದೇ ಟೀ ಬ್ರೇಕ್ ಕೊಡ್ತಾರಲ್ಲ
So please settle down, everyone. Session is about to start. Everyone, please settle down. The session is about to start.
What's your last three numbers?
ಲಾಸ್ಟ್ ಮಿನಿಟ್ ಫೋನ್ ನಂಬರ್ ನೀವು ಫೋನ್ ಫ್ರೀಯಾ
I'll send him the pictures.
Yeah, yesterday was good.
Send a buy also.
Bro, I can't read all this. Bro, I sent to you.
I think you just take the test. You look
Ah,
just from this to this.
that's not like that.
Yeah, it's who's there?
Good morning to one of our present here. We are delighted to host the third keynote session. It is our privilege to welcome Dr. Sheldon Williamson, whose distinguished expertise and influential contribution has significantly shaped this field. We are honored to have him and look forward to the insights and perspectives he shares with us today. Dr. Sheldon Williamson is a fellow of the IEEE Society, a globally recognized leader in transportation, electrification, and electrical energy storage systems. Dr. Williamson earned his bachelor's degree with honors in electrical engineering from the University of Mumbai in 1999, followed by the master's and PhD degrees with honors from Illinois University of Technology in 2002 and 2006. Dr. Williamson is currently a professor in the Department of Electrical, Computer and Software Engineering and is the director of the Smart Transportation Electrification and Energy Research Group at Ontario Tech University. He leads a cutting-edge research aimed at accelerating the transition of Canada's transportation industry towards smart electric energy storage systems and fast traveling infrastructure. His research interests span advanced power system electronics, electrical energy storage systems, and motor drives, with strong focus on enabling efficient, reliable, and sustainable transportation electrification. In recognition of his outstanding contributions, he currently holds the prestigious NSERS Canada Research Chair in Electrical Energy Storage Systems for Transportation Electrification. Dr. Williamson work bridges academic excellence and real-world impact, shaping the future of smart and sustainable transportation systems. On behalf of the organizing committee of ICISPES 2025, I invite Dr. Sheldon Williamson to take over the session. I would also like Dr. Varaprasad to take over the session. Yes, sir.
Yeah. So very good morning to one and all. So today, on behalf of preoccupied condition, Professor Sheldon is unable to join. So on behalf of me and Dr. Getty, the Professor Sheldon Williamson is me, going to present the topic on advanced wireless technology for electricity. So before going to the topic, we would like to throw some light on the sustainable development goals, like where the current EV technologies are and what is the significance of the wireless charging, which has an impact on the global levels, particularly on the rapid pool of affordable energy and industry innovation and infrastructure and sustainable cities and communities, as well as responsible consumption and production and gas. So these are the targeted goals in particular for focusing on these particular technologies and how we help meet the goals and provide sustainable solutions for the affordability and existence. So moving forward on these aspects, especially this is the whole picture of the EV ecosystem that why these particular charging technologies plays a significant role for developing the future of smart grid, especially when we are integrating the renewable and bringing the wireless charging, especially for electric vehicles, are completely are interface with the wireless charging, and it will fit into the EV ecosystem and to that local completely also with micro. Moving forward in this future smart grid ecosystem where the EVs play a major role and the charging is the main criteria we need to consider for advancement, especially for the charging structures are concerned. So, what are the major top challenges in front of the EV transition, especially with respect to the infrastructure, the range, and the cost? So, this particular figure illustrates how the charging infrastructure plays a major role, especially up to 77% as per the global trends are concerned, and as well as the range anxiety. For suppose, as far as the EV transition is concerned, how we could give based upon the charging conditions, how much range it could guarantee based on the traveling conditions that will fall in the 73% and affordability of the charging infrastructure and its reach to the EVs will fall under 70%. And the safety and reliability of the system as well as infrastructure would be under 42%. And the charging technology means what type of charging has been extended for the EVs based upon the power levels as well as the kind of conditions will be fall under 15%. So in total, these are the top challenges when we are adopting the infrastructure, especially for EVs are concerned, in view of its range as well as its cost. So how do we achieve to meet the sustainable structures and infrastructure to reach the EVs to deliver the maximum capabilities and prevent the range anxiety and it would be affordable as well as for the reliability of the EV batteries. So the batteries are the plays a key role in electric vehicles when we are talking about any kind of EV charging infrastructure. It should match with the requirements of the EV batteries and the vehicle dynamics are concerned. So the major roadblocks in front of the e-mobility in particular and electric vehicles in general are the low battery and what kind of a charging methodology or charging structure will be considered and how it will be feasible. Because we are talking about EVs will overcome as to the sustainable development goal, it will act on the climate edge, overcome the conventional ICs, but however, how we could accommodate the charging for the EVs, keeping all the things that feasibility of the charging infrastructure and thermal management and its ability to meet the range. So these are the major roadblocks to overcome while we are planning to design any kind of a EV charger. So moving forward on these aspects, this is the impact of how it could impact on the conventional system as well as the connected power systems. Totally, in global level, it could go up to 800 terawatt hour by 2030 that the total consumption has been forecasted. And the demand of the electricity, in particular for the EVs are concerned, is expected to be 3.9% globally by 2030. So the spend of infrastructure is capable to meet these requirements with a sustainable efforts without impacting the grid stability and also power quality. So these are the main things need to be considered as in when we are talking about any kind of charging infrastructure or technology. And the second aspect is what type of battery technologies are adopting while choosing these particular charging infrastructure, especially if it is a wireless charging or connected charging, whether it is capable to deliver the power level and meet the charging duration as per the battery requirements are concerned. So, in in general or in particular, the existing current battery technologies are these lithium-ion, and currently we are going to learn about all these kind of battery chemistries, in particular solid state batteries and LFP batteries. So these are some of these technologies are growing now and adopting by the EV manufacturers. So keeping these kind of battery chemistry is also important to meet the charging requirements, the charging voltage based on the battery pack voltage is concerned, as well as the charging time to meet to deliver the maximum range as per the design EV charging capabilities are done. So all these aspects are important. That means what type of charging and how to state if we are promising to the user based on the EV structure is concerned, and what type of battery chemistries are considered for charging. So these are all plays a major role while designing the charging technology. As we are discussing, the current one would be a wireless charging. However, in general, this plays a major role before going through the charging infrastructure. So, moving forward, the batteries plays a major role and it has different chemistry, and the other major component belongs to the EV batteries. While we are designing the charging infrastructure is the type of battery pack and what kind of cell structure is considered in the battery pack, and what type of battery management system and how it is connected currently. Our group is focused on these battery management system exclusively in terms of its connectivity, that means like online DMS, and also thermal management, how we could ensure the health conscious of the battery pack to provide the maximum charging without impacting its thermal runaway. So these are the major aspects also necessary to consider as part of the inside of the new battery structures are concerned. So all these aspects are important before discussing any kind of charging technology, whether it is a wireless or a non-board. These configurations are important to consider for designing of the charging technology. So this particular figure shows the current ongoing research in steel group of Professor in the where we are particularly focused on the smart health conscious charging. So in this picture, you could see the kind of a BMS based the charging battery pack design has been shown in this. So, and the test facility in Ontario Tech University, where we could test the battery dynamics as well as the vehicle dynamics and its behavior under different weather conditions. So, this actual figure shows a wind tunnel where we could accommodate different kind of weather conditions and test the behavior of the vehicle as well as its charging conditions as well. And we had in-house onboard charger like ABB based and the testing facilities, and we do the wireless charging testing in different weather conditions and the battery pack behavior also online, both online and offline. So this particular slide shows a complete picture of our facility that how we could accommodate all these charging conditions with an online PMS and its testing and validation capabilities for uh, practically created weather conditions and its behavior analysis. So these are also important because before deploying into the real conditions or real infrastructure deployment, the testing is very important before because we used to have different industrial projects where we used to consider the validation of the infrastructure behavior as per technical readiness levels from 5 to 7, where we could accommodate as and when we develop any kind of a charging methodology. The feasibility of this for the current EV trends is meeting or not, we will verify. So coming to this particular slide, it is illustrating the basic futuristic topics, especially for the e-mobility advancements are concerned. We are also working some of the industrial projects where we are currently working on monitoring the state of health as well as state of charge, and also in terms of thermal conditions online using artificial intelligence techniques to understand the behavior of the charging cycle and how we could accommodate the infrastructure as per the need of the battery pack conditions. And also, we are currently working on the drone charging, the wireless charging, where we could accommodate different types of drones, like delivery drones and monitoring drones and farming drones. So, in these kind of applications, how the drones plays a major role and how we could accommodate the charging for those drones, as well as the supercharger technology. In particular, we are working on from 50 kilowatt power level to up to 150 kilowatt. The projects are going on, which is similar to the supercharger technology by Tesla. So currently, it is ranging from 350 kilowatt to 500 kilowatt. And also, we are looking at the fleet of school buses where we could accommodate the electrical buses with DC fast charging as well as the wireless charging capabilities. So meeting the market demand of up to the USD like 15,000 to 159,660 million, where these numbers are changing, but this is the significant forecasted figures as far as the EV market is concerned to provide the EV charging infrastructure. So on these figures, the basic testing capabilities and this topic. So, moving forward to the energy transformation. So there are currently, if we consider the good old trend that conservation of energy, so how we could transform the energy in different forms has been illustrated here. So in that, EVs, that means how the electrical energy is transformed to the EV dynamics is one among them. So to have this particular application, how the infrastructure is needed to make the charging effective for meeting the demand of the EV charging requirements. So, so this particular figure illustrates the whole picture of EV charging accommodations. That means it could come up with a conventional level 1 charger, which is connected on board, as well as it has a feasibility to connect with the DC fast charging station. And also, you could see in this particular figure, there is a possibility to do the wireless charging. So, this entire accommodation will illustrate the capability of EV charging in different kind of charging mechanisms, starting from level 1, which is shown on the left side of this picture for charging the onboard charger. If not, there is a feasibility to connect through the DC fast charging station, and also we have a capability to do with wireless charging. So these are the typical structure for charging to accommodate the EV batteries for charging mechanisms. So currently we are discussing about the wireless charging in particular, but these are the whole picture in front of these charging mechanisms. So the basic charging technologies we could be classified as shown in this particular flow chart. That means we have a different kind of charging technologies, especially stationary and overnight, and also in. So stationary and overnight has been further classified into two types. Those are wireless and conductive. Most of you are aware of it that the conductive charging is like AC level 1, based on this residential type charging. AC level 2 is somewhat residential commercial and most running from the higher voltages. And DC fast charging is completely like high power charging condition. So coming to the other side of the coin, we could see the wireless charging has been further classified into two types, such as inductive power transfer and capacitive power transfer. So these are couple configurations for the wireless is concerned. And also currently the research has been focused on these particular aspects like in-route charging. So in particular, if you consider in this particular in-route charging, we have the further classification as opportunistic charging. That means there is a capability we could do the charging quite often as per the stops of the vehicle is concerned. Like if you consider, for example, any kind of the public feed or transportation buses, where it has a frequent stop. So as and when it has stopped at that particular stop, it has the ability to charge dynamically. So that's called in-route charging as per the public grid is concerned. Further, we have conductive charging, which is typical to a underground charging. It is one of the dynamic charging mechanism. Further, in-motion dynamic charging is further classified as wireless and conductive. So the wireless would be on the part, that means the whole rack, it will be accommodated with the charging pad. So in motion of the vehicle, it is supposed to be charged on the further. Another one is conductive charging, where it has a pantograph or a rail type of sliding contacts will be there, which will be accommodating the charging packs on the surface. So which will do the in-motion dynamic charging for the vehicle. So in total, these are the different types of charging technologies that are available as per the EV types are concerned, as well as the charging types are concerned. So moving forward, if we consider the conventional lightning charging, these are the different levels. As I mentioned, the conductive charging has a level 1 for the residential, level 2 has the residential and commercial capabilities, and level 3 will be the DC fast charging. So if we consider in this particular picture, we could see the level 1 charging has overnight capability that it needs a minimum time of 2 to 5, and it has a miles of range per hour. So we generally used to do this for family homes like apartments and commerce structures. So coming to the level 2 is little more as per the miles of range per hour is concerned. So it is also found between the residential as well as the commercial fleets are concerned. So coming to the level 3, it is completely a DC fast charger. So the duration is 400 from 25 to half an hour, where it could guarantee up to 150 to 350 plus miles as per the range is concerned. So it could be used in public and multi-unit residential buildings such as apartments. So these are the classifications as to the flexi charging is concerned. So moving forward, these are the different types of plugs that are available, especially when we talk about AC connectors. So these are the plug types of the plug-in charging for the electric vehicles are concerned. So if you could see, as per the geographical locations are concerned, they have a different type of plugs. So it has been transferred further as AC connectors and DC connectors. So DC connectors in particular used for the DC fast charging. So the DC connectors could be used for level 1 and level 2. So worldwide, Tesla has the same configuration of the flash structures, whereas in different domains like in North America, so this is the connected types for the AC connectors and these are the DC connected types. So this is just for an outline to understand the basic types of conductive charging as per the classification is concerned. So now coming to the wireless charging, most of us we are aware of with the smart devices such as smart mobiles, smart watches, as well as wearables and the hearing aids. All of these are now available with the wireless charging capabilities. And also, these can charge each other, even though without having a dedicated charger. A wireless mobile can charge a wireless uh, watch or any kind of wearable. So it's like device to device charging using wirelessly. When one device has fully charged, it could share that charging to the magnetic device. So, no, but this is the same technology or same kind of a methodology could be adapted for the electric vehicles as well. As far as the charging pads are concerned, and as far as the device charging is concerned, the same application could be extended for the EVs as well. So that is the reason why as all these smart devices are playing a major role in our day-to-day life, similar to the transportation, the wireless charging also plays in a similar role because of the advancements in the power electronic converters and availability of the different kind of materials and the nanoscale materials for developing the charging pads, it could be extended for high power wireless charging for the vehicles as well. So then how this particular wireless power transfer technology has been introduced. It is not a rocket science or it is not introduced just right away. It has been there since starting from 1897 as per the Nicholas Tesla point. He has filed his first patent in 1897. Then he has introduced in 1901 the Tesla tower, and further it has taken power by the inductive coupled coils to the closed chest, so wearables and for the biomedical applications in 1961. And in 1990, from the University of Auckland, tested their first WPT system. And further, it has been validated in University of Hong Kong for coreless PCT with WPT concept. Currently, we are talking about the wireless pads with the planar magnetics. That is also one of the developing advancement in the wireless charging. Another one is in 2007, America has the first experiment on wireless power transport, and in 2008, the Intel WPT experiment. So these are the timelines illustrating the history of WPT and its operating principles since its inception from 1897 to 2008, and currently it is forward for the EV charging. So, coming to the wireless power transfer in particular, it plays a significant role apart from the conventional onboard charger or DC fast charger. You know, to overcome the different level requirement, because I just presented in the previous slides that we need a different kind of charging plans based on the type of connectors, whether it is AC connectors or a DC connectors. There are different requirements. However, if we consider the case of the wireless power transfer, in particular for EV charging, it is uniform and universal for different vehicles. They don't need any kind of a flag requirement. That is one advantage. And the kind of couplers, that means what kind of inductive coupling or capacitive coupling we are using. Based on that, we could increase the power levels as per the requirements of charging. So it would be governed by the standards. Generally, currently the wireless power transfer standards are governed by SAE J4952, and the IEC standards are also impact on that in terms of power transfer capabilities as well as the electronic conditions and disagreement tolerant hacking capabilities, and also kind of battery chemistries could be feasible to guarantee the maximum range, and also the cost and reliability. So these are the factors which will impact in terms of charging is concerned when we are testing the wireless power transfer. So these points will summarize those requirements why we could go for a wireless power transfer technology over the onboard or wired EV charging methods. So this is a basic concept. So there are two types of coupling configurations as per the wireless charging is concerned. That is, one is inductive, another one is capacitive. So this concept shows the concept of inductive power transfer, where the power supply is goes from the whole configuration. It goes from the grid connected, then it has a front-end converter which will do the AC to DC. Then it has a power supply or any kind of interface, or we generally consider high frequency inverter to convert from the DC to high frequency AC. Then it has been connected with the resonance circuit, which will act as a coupler between the grid as well as to the vehicle. Then it will transmit the power or transfer the power to the vehicle where the receiver side is connected. So in the receiving side, we have a rectifier which will convert the high frequency AC to the battery capabilities. So the DC. So basically to the high frequency AC to DC conversion. So the measurement circuit as per the standard designed for 85 milliamperes. So the principle goes based on these principles, that is Ampere's law and Faraday's law. So this is the whole concept of an inductive power transfer. If you could see from here the basic supply. So it would be a grid supply when we are giving from an AC, or if we are considering a direct AC, then it replaces the front end converter with direct power so that it will do a high frequency AC conversion through the compensation network to the coupler, and from the coupler to the receiving side, it will convert the high frequency AC again back to the DC to charge the battery of the electric vehicle. So it would be either as per the supply type and the converter configuration, the conversion process will be decided. So this is the basic blocks of inductive power transfer, where the advancements are going on in terms of the design of this power converter and reducing the number of stages, whether we need to have a two-stage conversion or a one-stage conversion. At the same time, the secondary side, usually we use to consider a uncontrolled rectification, but nowadays we are using the controlled rectification with the control power converter on the secondary side as well, which is able to do the vehicle to grid and grid to vehicle condition. So these are the advancements currently going on in these particular concepts, and currently the steel group is working on design of single stage converters, matrix converters for the wireless charging, as well as adaptive compensation for the couplers to to accommodate the misalignment tolerant conditions to charge the electric vehicle effectively. So these are the advancements going on in this particular structure is concerned. So moving forward, as the configuration is illustrated here, this particular table illustrates the power levels of the charger. That means what would be the maximum power capabilities going from 3.7 to 7.7 and 11 kilowatt. So currently we are validating the 11 kilowatt and 20 kilowatt wireless chargers, and the research is going on the design of the couplers and composition methods for these chargers. And working on, as I previously mentioned, the front-end converters, whether it will be dual stage or a single stage, and the secondary side active rectification, and also accommodating the vehicle to grid and grid to vehicle conditions. So these are the basic levels of charging using wireless power transfer as per the standard. In this slide, it illustrates while designing the power converters, so what type of frequency we could consider as per the switch nature is concerned, and what type of power level it could accommodate for that. So in this, we could see this particular graph illustrates the range of switching frequency is capable to deliver for operating the power converter switches as per the power levels. So earlier we have heard about the IGBTs up to going from 10 kHz to 100 kHz, but moving forward, if we are using the megahertz switching frequency, currently we are capable to use the silicon carbide based switching devices, which could accommodate the higher switching frequency and high power levels. We could see here it could accommodate up to 1 megawatt. That means the silicon carbide MOSFETs as well as gallium nitride switches are capable to meet the requirements of high power charging. So currently, the power switches also plays a major role while designing these power converters for the inductive power transfer. At the same time, the compensation network and the coupled configurations. So I'm going to show some of those design methodologies as well as the converter configurations done by Professor Sheldon Williamson's past students, as well as what kind of configurations we are considering. So before going to that, this particular slide illustrates the standard requirement. As I mentioned, the wireless charging has been considered based on the Society of Automobile Engineers J2954. So as per that, these are the different protocols from the grid connection till the battery. So these are the different standards and the protocols need to be followed as per the standards, and the design must accommodate these standards strictly. So if we talk about from the grid connection, we do have a power converter and its control is coupled with the compensation network, and in this one would be the coupler on the primary side and the secondary side, and the secondary side compensation network connected to the secondary side converter, which is doing the rectification, connected with the EV battery. So it has the regulation and control as per the J2954 standard, and it has a communication link between the two couplers to understand if we are talking about the bidirectional control, the information of the secondary side needs to be communicated to the primary side, so that communication protocol has to be developed, and it would be the CAN communication or wireless and whatever it may be, it has to be followed and strictly as per these standards. And coming to the another aspect is the vehicle side, the battery management system, and to understand the conditions of the battery charging, whether it is done or not, how much charging left over, and how we could accommodate the controls. So all these things could be covered by these protocols for controlling the charging from primary side to the secondary side. If it is an active rectification on the secondary side, it is a capability to feed it back to the grid that we could react to. So in all these aspects, these are the standard protocols need to be followed for the designing this concern. So this is very important. So moving forward to keeping all these standards in picture, currently the state of art with respect to the wireless power transfer in general, in particular the different types of inductive power transfer and capacitive power transfer. We can see here the blue circle illustrate the inductive power transfer developments in academia. That means it is not developed full scale in deployment has been not yet done. It is still in the research stage. When you see this square, IPT will be considered for industry which is in the testing phase, and the circular CPT is in the validation stage in academia. So you could see this particular graph illustrates the state of art of inductive power transfer and capacitive power transfer in terms of converter design, coupler configuration, compensation networks, where how it is going on, and how much efficiency it has been achieved, and what kind of coupler configurations and spacing are considered in different charging conditions as well as the coupler configurations. So these are the whole picture on different facilities and different institutes globally, how it is going on has been illustrated in this particular graph. So these are the different universities in North America and Europe, as well as, and these are some of the industries where we're currently working on the wireless charging, but the inductive power transfer. So currently, as per our testing conditions are concerned in Ontario, you can see our university here, we are able to achieve up to 94% in terms of wireless charging concern, and the kind of charging methodology we use is inductive power transfer. as I previously mentioned, I'm going to show some of the projects we executed and some of the projects done by professors, previous students are inductive power transfer and capacity power transfer has been accommodated and achieved up to 95% of efficiency in the laboratory level, and those are we are now moving forward with the commercialization as per the industry projects. So another aspect with respect to the wireless charging, this particular slide illustrates the what plug-in versus wireless charging capabilities and how it could overcome the limitations of the wireless charging. And moving forward with the wireless charging, there is a dynamic charging capabilities where the road has a capability to charge the vehicle in motion. So that is called as a wireless dynamic charging. That means the road has been, is provided with the charging pad to the entire road structure is concerned. It has the capability to charge the vehicle in motion. So by this way, vehicle don't need to stop and they don't have any wires, obviously as it is wireless. And there is no idle time because during the transit is going to charge the vehicle. So these are some of the advantages in respect to the wireless dynamic charging. So that is also one of the ongoing research on dynamic wireless charging, but it is not completely available for the physical fleet is concerned, but it is also in future aspect. It's going to happen. So these are some of the technologies that is focusing on the dynamic charging also. So now this particular slide shows the classification of different wireless power transfer systems as per the methodologies of concern, that is non-radiative near field WPT, as well as stressing on the words like IPT and CPT, like capacity coupling and inductive coupling. So these are the most research coupling configurations for the EV charging concern. And the other one is day2 This is another classification with respect to the charging is concerned. So it has a microwave power transfer as well as laser power transfer. So these are some of the aspects or methods available. So currently, we are working on this inductive power transfer and the capacity power transfer in most of the cases with respect to the EV charging or transfer. So these are the classification type. And coming to the charging system classifications with respect to the whole configuration of wireless power transfer for EV charging, as I have shown the previous block diagram, it has a primary side, which is called as a grid side, and secondary side, which is called on the vehicle side. So we have a primary side where we have different kind of power calculations like dual stage or single stage. Has again further classified into vehicle frequency type control, fixed frequency control, as well as the direct energy injection base. So again, the fixed frequency is further classified into pulse modulation based control and DC voltage regulation with respect to the primary side. And secondary side also we have an active rectifier, a buck converter type, a boost converter type, a interleaving boost, and a cascaded buck boost. So these are the classifications as per the type of conversion is concerned on the secondary side, which will be classified on the vehicle side. So primary side will be big side and secondary side will be the vehicle side. And dual side control. As I mentioned, if we are talking about B2G and G2B, it would be on dual side. So these are the power converter control schemes with respect to the grid side conversion as well as the vehicle side conversion. So these are the typical classifications as of now with respect to the different control configurations are concerned for the wireless charge. So coming to the primary side, these are the different inverter topologies. This is one of the publications by professors previous students. So there are different types of configurations like this is the most accepted configuration like a bridge converter. So the classifications are defined as push-pull configuration, the A figure with illustrate, and this one is a off-peak current source inverter. and this will be a full-bridge current source inverter. And again, the figure will illustrate the buck configuration, and this will be half-bridge voltage source inverter, and this will be a full-bridge voltage source inverter for high frequency conversion. So these are the available configurations. Currently, research is focused on enhancing the capabilities of these primary side converters, at the same time the secondary side converters as well. So, and also we are currently working on the multi-level configurations and reduced switch count converters on the primary side of the wireless power transfer by different master student support group to accommodate the high frequency conversion as well. So coming to the as per the block diagram of wireless power transfer, after the converter, I mean the inverter configuration, we need a compensation network. So this particular slide illustrates the different types of the compensation networks as mentioned here. The series capacitor configuration and LCL configuration, LCCL configuration source here, and parallel series capacitor configuration and parallel capacitor configuration. So these are the different configurations in terms of the compensation network is concerned, as well as the converter configuration. The VSA shows the voltage source inverter and CSA illustrates the current source inverter as depicted previous slide. So these are the front-end converter and compensation network classification. And as I mentioned, there will be two types of configurations. That means dual stage configuration and single stage configuration. So dual stage configuration, we will have a front-end converter which will do a AC to DC. Then from the DC, it will convert it to a high frequency AC, which is up to a resonant frequency for the particular configuration as concerned. Whereas if we are going to replace that two-stage configuration, so these are the single-stage AC to AC conversion for accommodating the particular frequency for the resonant frequency. So these are some of the configurations our group members have explored in particular. So these classifications are defined as buck matrix converter, off-bridge matrix converter, full-bridge matrix converter, and boost-derived matrix converter, and bridgeless boost converter. So these are the different configurations with respect to the front-end side, single-stage AC to AC conversion is concerned. So moving forward, this is on the primary side. So this is the basic illustration that what types of static wireless charging configurations are we are exploring. So this particular slide is developed by the Qualcomm structure for static wireless charging. So the different power levels in terms of wireless power transfer. But in particular, the integrated power transfer is concerned is classified into different power levels like 3.7, 7.4 to 7.7, and 11 kilowatt and 20 kilowatt. Currently, we are exploring these power levels for the electric power transfer with different oil configurations and compensation networks. So, this particular slide illustrates what are the major blocks or major parts in terms of wireless power transfer, in particular static wireless charging is concerned, as been illustrated here. So another one, as I mentioned in the classification level, the pantograph based charging. So this is one of the type of wireless charging, but in terms of a pantograph on top. So as of now, so far we have discussed those technologies. The ground level, that means the charging pad is on the surface, and the vehicle is accommodating on the surface to charge through wireless. But let us say, if it is on top of the vehicle, then it would be like a phantom lock base. But however, it is not in contact, there is a spaces there. So according to the charging would be accommodated. So the thing is, the structural differences matters, but the kind of configuration and the converter and the composition network would be the same. But the only thing, the structure and the placement of the charging pad as well as the design is only changes. So that is only the illustrational difference between the static wireless charging on the surface level and the packet level. So these are the two things to be classified in terms of the charging advancement of wireless charging is concerned. So in this, these are the different types of inductive couplers we explored in terms of the charging pads are concerned. In particular, the couplers are classified as circular type coil structures, rectangular, square, and a DT coil structure, and DT coil structure, and bipolar configuration. So these are some of those coil configurations with respect to the inductive power transformation concept. And currently, we are also exploring the rectangular based coils for the asymmetrical structures as well as the bipolar configuration. So the couplers are also plays a major role while designing the charging conditions of the EVs in terms of high power to the different power level configurations. So moving forward, as I mentioned, Kumar is one of the professors student who worked on 3.7 kilowatt inductive power transfer system. Initially, he has developed the laboratory scale experiment and verified for the misalignment conditions and developed the calculation for the wireless transfer. So this particular slide illustrates his work with respect to the primary side active converter. The secondary side converter is uncontrolled one, but this is the conventional 3.1 kilowatt inductive power transfer system. He has been developed and validated. And further, Deepa Vincent is professor, one of the former PhD student who worked on the coupler configuration. The interesting thing here is it's both. If you see here, the coupler would be both capacitive power as well as inductive power transfer capabilities. And also, it has a secondary side active rectifier, which is capable to do the grid to vehicle charging at the same time when the charging surplus and it can able to carry it back to the grid for V2G configurations as well. So this is one of the work which is done for where the advancement is on the coupler configuration for hybrid CPT and hybrid. CPT means capacitive power transfer and IPT means inductive power transfer. So this is one of the previous work. And also, 11 kilowatt hybrid IPT and CPT. As previously I mentioned that the coupler configuration has been explored for both the different types of IPT and CPT. So this is the basic circuit configuration with respect to the transmitter side as well as receiver side configurations of the wireless power transfer ranging from 11 kilowatt. So this is the laboratory scale setup verified for the hybrid coupler configuration for the IPT and CPT and validated with this one. And is able to achieve up to the 95% of efficiency under laboratory conditions, and it has been further taken forward for the commercialization as well. So another one, as I mentioned, as for the basic wireless charging block representations are concerned, the front end side replacing the dual side conversion has been replaced with a matrix converter, which will do the AC to AC conversion. On the rectifier side, it will use the AC to DC as an active rectifier as well. So, in this, the advancement is in the previous work, the advancement is on the coupler calculation, it is both IPT and CPT. In this, we consider the IPT, but the converter side, it is not dual side, it would be a single side conversion on the front end side, which is matrix converter based. So, this is the advancement in this work for implementing the inductive power transfer for EV charging, which is capable to accommodate both grid to vehicle and vehicle to grid configurations. So these are the configuration conditions that it has been designed for a 1 kilowatt laboratory prototype with a primary side voltage of 120 volts and the battery voltage for charging is 250 volts. And the resonant frequency as per the standard is 85 kHz, and the area between the two couplers will be 170 mm, and as I mentioned, as 90%. So in this advancement is the converter configuration. So like I mentioned, there are a lot of research going on in each stage in terms of power electronics, in terms of composition networks, in terms of coupler configurations, as well as on the secondary side active configurations. So this is another industrial project. We worked on the e-scooter wireless power transfer is concerned. As this is comes under the micromobility configurations where we develop the compensation network is an adaptive. That is the advancement in this. That means, as previously I mentioned, there are different kind of compensation networks we consider for the inductive couplers. So how we could accommodate different compensation networks adaptively as per the alignment is concerned, and how we could change the compensation networks as per the need for the better power transfer capability and better conversion, and to meet maximum power transfer and better conversion efficiency. So to achieve those objectives, we developed an adaptive compensation network. So you could see here, this would be a primary compensation and this would be a secondary compensation. We decided again to accommodate on the secondary side adaptive compensation to make the different kind of alignment conditions and to achieve maximum efficiency with an adaptive control. So this particular setup illustrates those conditions, and this work has been done with one of our former master students, Niranjan and John. So they have implemented the whole setup and validated for the e-scooter configuration. The configuration is rated for 270 watts, and currently now we are in the commercialization stage with one of our industry partners. So moving forward, so in this work, this is the basic illustration of the block diagram of the previous work as I previously mentioned. The e-scooter configuration is rated for 270 watts. Further, it has been extended for an EV charging rating of 3.7 kilowatts. So as I mentioned, we have implemented for LCC and series configuration and dual side LCC configuration, where we would change the composition network adaptively between LCC to S and dual side LCC. So the charging configurations adaptively we could swap for achieving the maximum power transfer as well as conversion efficiency. So this is the zero power angle control we have achieved to have a circuit efficiency. And further, so this is the equivalent circuit representation of the double side LCC compensation network, as the main focus is on the configuration of the compensation network. So here, so that's why the main emphasis is on the compensation network here. So we consider these configurations for the different types of charging modes like CC charging and CB charging, constant current and constant voltage. So in constant current, we consider the double side LCC, and in the constant voltage, we consider the LCC and series compensation. So the advancement here is, in terms of CC, we consider this particular compensation network. In terms of CB, we consider this compensation network. So starting of these calculations are advanced materials. So these are the different prototypes, and I'm going really quickly in the matter of time. So these are the different calculations currently we are working on. As I mentioned, Joy is one of the master student working on different types of coil structures in terms of bipolar and using polar calculations. And we are also working on the single input multi-output configurations for e-scooter and different micromobility applications where the primary side converts is single and secondary side we have a multiple network. And we have also explored in terms of resonant inductive wireless power transfer system for adaptive wireless transfer. So in this, the advancement is the secondary side alignment information has been fed back to the controller to ensure it is properly aligned or not. By doing the impedance matching, according to that, the charging will be initiated precisely. So this is the configuration what we explored in this. We could see here to understand the impedance matching. We have a S1 and S2 configurations are there. As per the placement of the couplers, so once it is properly aligned, it will sense and test the configuration. Once it is perfectly aligned, the switch 1 will be open and switch 2 will be closed. Then the charging will be done as per the inductive coupler configuration is concerned. So here, the impedance matching and understanding the reflection between the primary side and the secondary side has been verified. According to that, the charging is initiated. So that is the main criteria behind this inductive charger. So this is the logic we built and implemented practically and verified for the calculations. And these are the results we achieved. It's kind of a soft start mechanism we achieved, apart from the conventional thing where we could accommodate, because when we are talking about for the higher voltages and high power levels, the soft start plays a major role for the initial charging to prevent any transient conditions and to keep the health of the batteries intact. So, and these are some of the works with respect to e-scooter, but however, these are also adaptive compensation for hybrid compensation is concerned. And we implemented a type 2 based linear PI controller for controlling the charging configurations and triggering the primary side converter. So it has been accommodated with CC and CV mode, and this is the basic block diagram of the digital control implemented for a rapid configuration. And these are some of the results. Precisely what we could say, we have achieved nearly 92% of efficiency in both 270 watts scooter and the electric vehicle. And it has provided a successful results by considering the practical data as well as the real world conditions. And we verified for different charge configurations and different levels, and we validated that one by considering the battery equivalent resistance and understanding the behavior under both constant current and constant voltage charge. And we verify based on the input power and output power matching and how we could able to reach for different variable direct conditions has been illustrated in this particular thing. So moving forward, the same configuration we have implemented for each scooter, only the coupler configuration and the power levels are different, but the configuration is same, and we tested successfully. And these are some of the results with respect to the e-scooter. And you could see here, we have verified for different equivalent resistance of the battery, starting from the CC mode to the CV mode, and we are able to achieve up to 92 to 93% of efficiency randomly on that. So, but however, the testing is in progress. And these are some of the calculations we are currently working on for both V2G and G2B, especially for the control. The power levels, as I previously mentioned, we have already validated for different calculations. Now we are working on. So these are some of the works we are currently focused on. We are also working on the primary side form and it's control with a different direction. In 5 minutes, I would like to throw some light on cybersecurity conditions of the wireless tracking, because people are talking about everything is going on wireless and the control and all aspects. So there are a lot of communication as well as control is involved in this wireless thing. So all these terminals of the control as well as the communication has been exposed to the cyber threats. So what kind of cybersecurity considerations are necessary, and currently what we are working on it has been just summarized in these slides. So in particular, this is the whole picture of both conductive and inductive charging. So the conductive charging is a conventional type like AC as well as DC fast charging. You could see here the wireless charging is like this. So it has the main thing we need to focus on the control as well as the coupler calculations have been exposed to the cyber threats. So it is necessary to ensure the proper protocol has been having a proper communication uh, without any impact of the cyber threat. At the same time, the control interface as well. So this is very important when in terms of grid connection to any electric vehicle is concerned to protect from the cyber threats. So these are the whole picture of the system. It is connected not only to the grid, it is connected with everything as wirelessly. So it will tap for the behavior of the system wirelessly in terms of charging or in terms of communication or in terms of the range conditions are concerned. Or misguide the system that it is not charged or it is all the charging is done like that. So it should not happen with respect to the cyber threats or concerns. So this is an ecosystem. So how the electric vehicles are connected wirelessly in terms of communication and control. So then what are the threats here? The majorly we could see here the attacks on the microcontroller units, which is doing the control job from the wireless charging. At the same time, the communication of electric vehicle supply equipment in terms of cloud as well as in terms of the charging stations and others. So these are the different attack surfaces and how it could impact, like the loss of load that is disconnecting the system and modification of the data, stealing the data, or injecting any data noise or false gatekeeping will impact the behavior of the charging as well as impact the behavior of the working conditions of the system. So these are the things need to be taken care. Not only designing the controller or developing the power electronic converters, but also the cyber physical system is also important, which will be prone to have a resilient system to withstand these attacks and to do the job effectively. So these are the potential threats we explored, like denial of service and false data injection, man-in-the-middle attack, and physical attacks. These are some of the classifications currently working on in terms of EV charging, especially in particular the wireless charging is concerned. And these are some of the potential mitigation strategies we are exploring in terms of authentication and finding real-time intrusion detection and anomaly detection, and how we could verify the regular audits, and how we could provide a multi-layer defense, and how we could design the control with a cyber-informed engineering. That means the control is accompanied with authentication to ensure the reference is authenticated or it would be a false thing like that. So I would quickly summarize the dynamic wireless charging. We just explored some of the techniques like dynamic converters, as well as the cyber aspects in terms of dynamic wireless charging. So we explored some of these configurations in terms of control and the transmitting conditions. We explored the injective from the customer availability. Yeah, also explored hydrological system as well. So moving forward, in this hydrological in terms of dynamic charging is also the same, and we are currently working on to improvise these things in terms of communication protocols and algorithm control. So this is the cyber vectors we are currently focused on to develop some of the solutions, and we have a couple of industrial projects in this, and we are exploring on these things as well. So, in summary, concluding the whole talk, this is the future in with how it could accommodate for the energy efficiency. As in the beginning, I have mentioned to have a sustainable electric vehicle ecosystem meeting the future smart grid requirements. These are some of the futuristic e-mobility things. We are exploring like energy efficient, the public fleet like transportation buses. So it is concerned. At the same time, e-drones, as I mentioned, for different applications. Smart EV charging infrastructure, that means, as I mentioned, we could charge the device-to-device charging. That means our mobile phone is able to charge our smartphone. At the same time, the electric vehicle also charge vehicle to vehicle. So, like that, the charging infrastructure is smart and it could share between the different populations. And also BTX, that is another thing I mentioned, that means not only to the grid, it will be given to your house or it will be given to any kind of load, so vehicle to anything. And electric vehicle takeoff landing is kind of a classification from the drones classification, further it would be go for a e-taxi. And hyperloop is also one of the transportation advancement. And also artificial intelligence, I haven't, because of the time constraint, we haven't explored much on artificial intelligence, but artificial intelligence plays a major role in terms of health conscious traffic charging, as well as cybersecurity, as well as the control nature and the vehicle range. In these aspects, artificial intelligence is also exploring to decide the control and to decide and maximize the charging capabilities and to work on the thermal runaway of the EV batteries as well. And as I mentioned, shared capability is also one of the futuristic capability applications between different kind of 3D concept and so on. So in total, so these are the whole picture of advancement of charging technologies in general and wireless charging in particular. So the research is going on and it is exploring in multiple verticals, but it will definitely will ensure the requirements of sustainable development. So with this, I stop here and thank you for giving me this opportunity. I would thank my Professor Charlotte Williamson as well as the organizers for sharing our views and thoughts and into the wireless. Thank you.
Thank you, Dr. Thank you, Dr. Varaprasad. Does the audience have any questions for sir? Okay, thank you.
And Professor is in call. I couldn't see Professor Charlotte Williamson on call.
Yes, I'm here.
Good morning, sir. Dr. Williamson?
Yes. Good morning. How are you?
I'm good, sir. Good. Sir, thank you for your session.
Very good. Yes, you're welcome. Thank you to Dr. Olamaki for the lovely sessions. I was listening. Yes, thank you.
Thank you, Mr. Varaprasad.
Yeah. So I'm okay to exit from this side. Thank you.
I would like to thank Dr. Varaprasad and Dr. Shailesh Williamson for their insightful and thought-provoking address. We sincerely appreciate you for taking your time and sharing expertise perspective with us today. Your contribution has been valuable to this conference. Thank you.
Technical session will start at 11 a.m. in building number 7 until it is served over there. You can move to building number 7. Thank you.
Excuse me, just a mention. It's more of your name. Apart from the stage and the technical people, everyone else has to go to the department. Technical also to the department. Yeah. Stage committee, please stay here.
Bro, one person is in live. Shall we go and tell hi?
You take your phone, you'll go there now.
Correct. Sir, sir, uploading, sir. Actually, my laptop only one laptop is I'll upload.
Which one? Yes, ma'am. Which one?
Give. आराम से no, sir. No, sir.
Yes.
Hey, you shut up and sit here. Wait. Here you go.
See, which one? Studio Pro. Download app.
No. Done. You click.
50% charge.
ರಚನಾ ಮಂಡೇ ಶೇರ್ ಮಾಡ್ಬೋದು ರಚನಾ ಮಾಡ್ಬೋದು ರಚನಾ ನಿನ್
If you planned anything, please postpone it to Sunday. Okay.
I am not coming now.
ಏನ್ ಬೇಕು ನಿಮ್ಗೆ
Organic farming, water conservation, waste management, food work.
ಎಲ್ಲೂ ಮಾಡ್ತೀರಾ ಇದು ಎಷ್ಟು ಗಂಟೆ ಆಗುತ್ತೆ
9 to max 12.
John, chewing gum. I'll be fine. Yes, ma'am. Okay, ma'am. Turn it 2 pages. Hey, wine, gold mug आएगा? Gold mug. Sexy super. Wait, wait. ಇದಲ್ಲ ನೀನು ಏನು ತಿಂತಿಲ್ವಾ ರಮ್ಮು ಇದೆ ಬೀರು ಚೆನ್ನಾಗಿದೆ ಜೀವನದಲ್ಲಿ ನಾಳೆ ಬದುಕಿ ಆಗೋದಿಲ್ಲ ನಾನು ಬಂದಿದ್ದೆ ಮಾಡಿ ಬಾಳ್ನಲ್ಲಿ yeah, seriously. With 4 and then directly. Nasha, hey, yaar, numbness. Get that back. Seriously. Hey, that's what Hey, John. Seriously. Yeah, problem at it. All the black stuff. Why did you break up song yesterday? What happened? ಕ್ಲೋಸ್ ಫ್ರೆಂಡ್ಸ್ ಯಾಕೆ ಅವಳು ಹಾಕಿಲ್ಲ ಹಾಕ್ಬೇಕಾ ಅವಳು ನಿನ್ ಫ್ರೆಂಡ್ ತಾನೆ
ಹೊಡಿತಾನೋ ದಬ್ತಾನೋ ಗೊತ್ತಿಲ್ಲ ಅಪ್ಪ ನಾವು ಆಂಧ್ರ ಬಾರ್ಡ್ರೆ
ಆಂಧ್ರ ಬಾರ್ಡರ್ ಬಳ್ಳಾರಿ
ನಾಟ್ ಆಂಧ್ರ ನಾಟ್ ಆಂಧ್ರ ನಾನೇ
This guy is the one thing other they can't bring 1%. You only pull 1% got that. She got that.
ನಾನು ಇವನ್ನೇ ಮದುವೆ ಆಗ್ತೀನಿ ಇವನ್ನೇ ಇಬ್ಬರೇ
Hey, ಭೂಮಿಕಾಳ
ನನ್ನ ಹೃದಯ ಐ ವಿಲ್ ಬಿಕಮ್ ಸನ್ಯಾಸಿ ಅನ್ನಪೂರ್ಣ ಸನ್ಯಾಸಿ
What
videos are going on? John Paul Govind.
ఎంతమంది ఉన్నారు
ఒక్కరిగా లేదు దాంట్లో
ఇది bro, two people are there.
Shoot.
Who is the two people?
No, it is not. It will start again.
Huh?
Open the page. Photo. Seriously.
Who are the two persons?
Bye, boy. My mom's. Your mom is photo. No. Hey.
Send it to me only, not in the group. Bye Ganeshan. Bye Ganeshan. Hey pipeline. Bye moms. Who is she? Hey, we see one thing happen. I should take more 3 seconds also.
Oh.
My mom. By the
Yeah, come now. Where? Okay, I'll take one. Come. We'll wait for them. Tea or coffee?
She coffee.
Tell me. We'll go for department. She already ran the papa. That later, no? 12:30. No.
Hey, you guys should change your vacancies.
Wait. Time out of back and number again. Bike ಅದು ನಿಜನಾ ಹೇಳಲ್ಲ ಹೇಳಾಡು ನಿಜ ಬೈಕ್ ಪೆಟ್ರೋಲ್ ದಟ್ bukan petrol bike ya bad not track voice
Such ఎത്ര సచ్చారు
Boya made it.
How many days you keep it?
Oh, 10 years.
10 years.
నేను పాపుల్దా ಮಾಡಿದ್ದ
How many days?
ಏ ಅನ್ನಪೂರ್ಣ ಬೇಡ ಅನ್ನಪೂರ್ಣ ಬೇಡ ಹೇಳ್ತೀನಿ ನೋಡು ನಾನು ಯಾವತ್ತು ಗಣೇಶ್ ಸ್ಕೂಟರ್ ಎಮರ್ಜೆನ್ಸಿ ಸ್ಕೂಟರ್ ಎಮರ್ಜೆನ್ಸಿ
My dad is a drink. Dad asked me.
ಆಟ ಬೆಂಗಳೂರು ಅಷ್ಟೇ ಅವ್ರು ಪಕ್ಕ ಮುಂದೆ
My dad is a drink. You don't want.
ಮನೆಯಿಂದ ಮನೆಯಿಂದ ಹೊರ
I want to jump from here, can I?
Bro, I should have recorded it. That's very random. You know what? Bro, wait. Do it again. 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 Oh, no way. You're going to post it on SKR. No, I won't. Do it again. You will.
Shivani, Shivani, I'm gonna post. No. Jump now. Wait. Jump. Jump.
There's a really shot.
Okay, first then you
I'll post you walking.
will leave it outside in sunlight, it look better, bro. Well, thank you, Ashwin, for bringing it. Oh my God, do I look that soft?
We can go, no, like.
You can come back with me.
Oh my God. I'll take you home. If you want to come home, you have to stay with Gandhi and stand here. It's all good. Hey, my bag is here. Oh, my bag.
Are we not
Actually, why are you not coming? Great record. Even I want to write. I'll come. No. Aishwarya. Ash.
She got an earphones back.
Bro. Bro. Where is he? We'll come back. We'll come back. You're there now. Speak, bro. Something I haven't understood. You found it good. No, what is that?
Nisha.
Nisha. Comfortable have waffles. Waffles. We have waffles. We have waffles. Shut up.
What do you drink, mom?
Guys, someone is there. What are you like?
Boya, will you come back to the auditorium for anything before the
No, that's
valedictory?
not I had out.
Before valedictory, you won't come back, no?
I think no.
Seen once and then you're drawing.
Who's this one?
Who is this? You have seen or you have seen from character?
You gotta take picture down here with us. No.
Akshaya, you got.
Shall I move this?
Live is going on.
Huh?
Live.
Oh, why?
Live is going on.
ये empty skin दिख रहा है. Why?
Now it's coming back. Wait and see. What is that?
Genuinely tell me.
Seriously, wait and see.
See, I move this. This is shame. Where are you going then? Yeah, okay. So what? I'll sit here and write record.
They want for me, I was going to take them. They never go out.
Read.
Please, Varna.
No, don't do too much. Welcome. Come.
Power bank class, no?
Power bank 100%. 60. Akshaya, is the laptop not an SD card slot?
Yeah.
No, I'll take my laptop. Actually, it is in live. Can't remove that. I just. Wait, I need cooler. Yes. Don't understand who is calling now, please. Mama, live is going, mommy, please. God. నేను మళ్ళీ ఫోన్ చేస్తా లైవ్ లో ఉంది ల్యాప్టాప్ ప్లీజ్ లైవ్ లో ఉంది మళ్ళీ చేస్తా delete that immediately finish storage I need my laptop. When live will started. Hello, you'll come in YouTube. Don't move there. We'll come in live. That's the charge finish.
This is enough for the shipping.
That's it. Where will keep camera? We keep charge there only. Battery will go off. Catch it. Keep camera cover. Set up. Call you for lunch.
Okay.
Hello, Shreya. 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 Hello. Hello. Shreya, do what? Do what? This is the. How was your day? Very well. That's a nice one. That's enough. That's enough. Hello. Hello.
Good afternoon.
Good afternoon, one and all present here. We are delighted to hold the keynote session, a central highlight of this conference. It is our privilege to welcome Dr. Vijay Misra, whose distinguished expertise and influential contribution have significantly shaped this field. We are honored to have him and look forward to the insights and perspectives he shares with us today. Dr. Prashant Mishra, an accomplished researcher and leader in intelligent cyber-physical systems, smart mobility, and sustainable infrastructure. Dr. Mishra is currently a senior scientist at Tata Consultancy Services Research, where he leads applied research on intelligent cyber-physical systems for smart and sustainable mobility solutions. He also serves as visiting faculty in the Department of Cyber Physical Systems at the Indian Institute of Science. His research interests are centered on optimization and decision intelligence for the efficient operation of urban mobility and infrastructure systems. He has authored over 60 peer-reviewed publications and position papers spanning cyber physical systems, Internet of Things, mobile systems, and electrical mobility. Dr. Mishra's contributions have been recognized through several prestigious honors. In 2017, he was named among MIT Technology Review's TR35 India's top 10 innovators under 35 and received the CS Exemplary Contribution Award. He is also a recipient of the ERCIM Alec Bestseller and Mary Curie Fellowship for Scientific Excellence and the Australian government's AUS-8 Australian Leadership Award Scholarship, recognizing his leadership potential and societal impact. Beyond research, Dr. Misra actively contributes to the broader scientific and policy ecosystem. He has served with professional organizations such as IEEE, ACM, and COMSNET, contributed to government agencies including MATI and engaged with standard bodies such as BIS and ISO or IEC. He currently serves as chair-elect of the IEEE Bangalore section, chair of the IEEE Industry Applications Society Bangalore chapter, and is a member of the COMSNET Association and the ACF India membership and chapters committee. I would like to request beloved HOD Dr. M. Prem Kumar to welcome the keynote speaker by presenting his sapling as a symbol of respect. On behalf of the organizing committee, ICISPES 2025, I invite Dr. Prashant Mishra to take over the session. Thank you, Dr. Prashant Mishra, for your insightful and thought-provoking address. We sincerely appreciate you taking the time to share your expertise and perspectives with us today. Your contribution has added great value to the conference.
People will come and come firstly. No one says will be.
I don't have food coupon.
Says, come and show come.
It's so bad. Oh, this is the guitar. This is pretty hard on the guitar, I find. You want to like it. It is part of the. It is what the. Can you do this? Do this test. Genuinely. Nothing.
get out of these. That's it, nothing, nothing. Oh, look at the Japanese start. Because the fewer by Japanese word fucking illiterate style. Their favorite style. I'm listening to some shit. Listen to this. Like, this is laughing. This is very nice, but I will take your apart. Cutting. What are you doing? This song. If I guess right. This is the very good study this one. It's going left, right, left, right. It's all like they're the same, but not recently felt pretty that doesn't happen in the past. That's it. That's it. Just shy. What are you doing? That's his face.
They do without this. Okay, I don't like that existing. It's better. And last one, the last one is loud. I was asking. Like, what is organization work history? What is national submission? Well, like, last year exams to recent running each fast stuff. Oh, that is There are also, yeah, font is a but well, it's fine. What the? So the defense is there, yeah. No, move the.
No, get it.
They didn't know that ANOVA thing. I know all the questions. Yeah, ANOVA. Oh, that's the place of Java. That's the target. No, that's it. Hey, my dad has me test. Yes, all. Yo, Shreyas, come here. Shreyas, don't get rain-baited. Come here. Come here. Nigga, how did they get this critical value? Where is it used? Oh, you have to get it from the table. And funnily enough, they don't give the value. So just remember to that's a great basket. So if T is not greater than critical, if you have to reject it. Yeah, yeah. They have given T. I know the T formula. You have to know T. They give you the points. What I'm here to calculate the T. Oh, small T. Oh, yeah, that's alpha. Now they don't confuse the square T alpha. This paper, you I have a fear of fast.
No, they did not give me a clear vertically start and
Yes, that AI in that paper was horrible. Brutal it was. Brutal.
the
Last. I think you did. But he's still like she has it in let's see. Paper was also manageable. You could at least get 40. Easily. Even if you get 40, she gets it 30. This nigga she gets. But yeah, ask also you get oh shit. Distribution of the data. It is quite yes. Lovely. What is cheap? To check if a line or a given row fits. Yeah, that is the good of it. Nowadays, I asked you that only G square has good fit as taken. It's two different things. No. See, determine whether observed frequency differs significantly. Good are very decided. It's not too difficult. Oh, test of frequency. Yeah. Yeah, test of frequency. That is the application. Yeah, yeah, that's true. Whether observed data fits test of frequency. And then you take different samples and then you take the compare. This is in a scenario where what are the two kinds of performance? Or okay, 0.049 less more significant than 0.0. That's what I'm saying. Should not be it's the same test. It is because even though it is 0.05 of an arbitrary value, it's very easy. You just have to
If you study, that's
like there is a statistical difference, but there is no real. That's the I hope they ask such things because yeah, Anua, what is Anua's analysis of variables?
Can we have something study last two modules? Study that, right?
See question, more question, two question. They're easy. You give me a signal and go up. But you give a signal. But what is the signal? Elevate. Bigger. No. It's just not here. Like this, like from here. But if you are fine, then just go up and down. Side and send it. I feel like we get caught. So lower shuffle because they're very strict. Or if I put your hand in your hair, you put your put your okay. Same for it's a like give you the chance. What is that? Statistical significance and practical significance. Bro, like something might be statistically significant. I know, you just tell me also. Like, wait, I have to explain the difference between both, otherwise you will understand. Yeah, so statistically, 1 out of 1,000 people being resistant to a certain disease, right? Versus 2 out of 1,000 people being resistant to a disease. Statistically, it's very different. But in the real world application, it's like 1 or 2. So, yeah, yeah. That's what they've done.
That's a game.
Bro, it has to be alpha or down. They've just given alpha is 0.05. They've not given it, but in this case, since they've given 0.004, even if you take 0.05, you have to take 0.05. It's still significantly less.
It's very good. What is X bar, whole X bar, whole square. I have the basic X square. I have to make something. X bar, whole square. Why is that? So how is my standard deviation at this is the patterns?
Shots of shots here, the kind of guy that thinks, device here. Do I not go that? Yeah, what is it? Tells it. She just thinks about it.
Hey, bro. Hey, okay, okay, fine. To tell you something, I'm going away. You're going for me. Bro, cheap shot. Listen.
No, God does that.
Listen, listen, listen. But I'll pay you back in my years. Give us the
Okay, I'll get it. So, right. So, if I get it, then, so the thing, so the thing,
That's what I do.
for one, I mean, no, if I'm getting one, you know what?
Bro, okay, I'm going, short term.
Check.
Let's know. Hey,
Prashant Mishra, whose distinguished expertise and influential contributions have significantly shaped. We are honored to have him and look forward to the insightful perspective he shares with us today. Dr. Prashant Mishra is an accomplished researcher and leader in intelligent cybersecurity systems, smart mobility, and sustainable infrastructure. Dr. Mishra is currently a senior scientist at Tata Consultancy Services, and he leads applied research on intelligent cyber physical systems for smart and sustainable mobility solutions. He also serves as a visiting faculty in the Department of Cyber Physical Systems at the Indian Institute of Science. His research interests are centered on optimization and digital decision intelligence for the efficient operation of urban mobility and infrastructure systems. He has authored over 60 peer-reviewed publications and position papers spanning cyber systems, Internet of Things, mobile systems, and electric mobility. Dr. Mishra's contributions have been recognized through several prestigious honors. In 2017, he was named among MIT Technology Review's PR certified Indian top 10 innovators under 35 and recognized the PSS Exemplary Contribution Award. He is also a recipient of the PRN Allen Alec Belsusan and Marie Curie Fellowship for Scientific Excellence and the Australian Government's AUST Australian Leadership Award Scholarship.
Come on, baby, please.
Beyond research, Dr. Mishra actively contributes to the broader scientific and policy ecosystem. He served with the professional organizations such as IEEE, ACM, and Tom Smith, contributed as a government agency secretary of NAPI, and engaged with standard bodies such as EIS and ISO. He currently serves as chair-elected IEEE Bangalore section chair of the IEEE Industry Application Society Bangalore and is a member of the Constant Association and
Hey, everyone, comment is that
Archit, laptop.
Huh?
Our phone yesterday's folder.
Uh-huh.
You have? I'll take it.
Go on.
Yeah.
It's in my hard disk.
Yeah. You have another laptop?
That's what I don't know. Another laptop, I should upload the photos.
Laptop is not there. Laptop. Akshaya, you have laptop. I want it 1 second. I want to transfer data to my pen drive. Yeah.
I gave to everybody. The girl is
You should save for me. I hate it.
uploaded.
Take that back.
I'm media. My laptop. Hey, where is Anurag page? Solution? They all ran out.
They went off, I guess.
Ran out. What was it? Like, never seen this. अच्छा शेष में ना तो ये कॉपी है game itself.
Connect both.
Yeah.
Smile with my eye.
I
You describe it. You describe it, and then you guess what I'm describing.
like push the things the option in the room. And then you say I spy this thing. How do you feel?
And we collected that thing is made. Okay, tell what you do.
That's why college study I was really sleeping.
And then I saw you will.
Yeah, they call
The legs are like it's okay. It's in the air.
that not sure that I
Oh, I didn't mention that. No one said that. She didn't try that bullshit. She think that is special. I'll shut this down.
Hmm. Boy, what's the point? Zero viewers only. No, not one single viewer. Every time I've been sitting here.
Join.
And do what? Give him money or donations.
Viewer.
Tell him-
He's a viewer.
Hey, what's that in your hand?
Pen drive. We amma, I am coming.
Hey, this was a camera, bro. Show me.
Watch for Indian.
Yesterday.
From every direction, bro. So you like find it.
So we do later.
Bro. I can't remember that picture. I won't be. Hey, these tiny people like so. Hey, the mind is there. Egg is there. Egg ram is there. Hey, I told you. I told you. Oh, you. Egg is there. You were there when I came. Us. Take pictures of me. Hey, wait, madam. Wait, madam. That's why. Enjoy you. What's your name? Oh, yeah.
Jamming session.
My God.
No,
Just made the. I mean, what do you at? I did. Oh, this I later edited. Like you can edit in that way. Hey, you have that lens cast, right? Oh, she didn't retract the lens. I go to work. I came from five. Annapurna, don't waste the battery. Don't waste the battery. I'm gonna take pictures of. Ah, bro, it's heating up.
Oh,
You scan the QR code, bro.
One was last year.
One. So I sit here. Ah, I sat here that zero viewers at
5 hours 26 minutes.
0 hours. 0.
We got from 6 from
I will take pictures. I will take pictures.
I'll keep my bag. No, it's fine. You're done with my laptop. Yes.
Yesterday's meeting. I couldn't, the picture came blurry. Right?
Yeah, you should that.
Yeah, yeah. So,
Teacher looks fat.
oh, yeah, show that. Hey, yeah, she looks fat. Yeah.
No.
Should have like this.
Bro, it's the same bitch. Not like
And if he's mad in the second, and she look at us and say, I love special with this. See, this guy's already sleeping. He's taking pictures. Hey, Akash, will you take pictures of this people? You know, click the photo here, no? When you just don't use flash. Flash, flash you use how to disable. This is so you can switch it off, but if you switch off the camera, so this. You take no? I'm still no idea the setting to change. It's a day. Like usually, will you be like when they give the plan, they'll be giving the plan, just make it for the plan from window. Go there, should go there. Fine, should be quick. Go trend, no focus. Take it. Shit, the last year, take it out.
if you want to see it,
Ashif, show me your camera.
Why is your eyes flipping?
yeah.
Yeah. Oh yeah.
That's mine, huh? Nikon, yeah, this is mine. Nikon.
It's cool. It's very.
ಅದು ಆಕರ್ಷಣೆ ಮಾಡ್ಬೇಕಾ?
That's
Hey, even I was telling you that.
why where is the Ganesh? Where is your information? What is session?
Oh, na. I guess he wrote Paris.
Script write this in like this. Get first 10 page paper. You should see the people's one technique is Have you introduced yourself? Introduce yourself.
Why did you suddenly? Ganesh, John, please start taking photos. Oh, no. It's your life. It's your I don't remember anything. When is she in
They won't switch off the lights or there's no sense. I think.
I know.
Good afternoon, one and all present. We are delighted to host the keynote session, a central highlight of this conference. It is our privilege to welcome Dr. Prashant Mishra, whose distinguished expertise and influential contributions have significantly changed this field. We are honored to have him and look forward to the insight and perspective he shares with us today. Dr. Prashant Mishra is an accomplished researcher and leader in intelligent cyber-physical systems, smart mobility, and sustainable infrastructure. Dr. Mishra is currently a senior scientist at Tata Consultancy Services Research, where he leads applied research on intelligent cyber-physical systems for smart and sustainable mobility solutions. He also serves as a visiting faculty in the Department of Cyber Physical Systems at the Indian Institute of Science. His research interests are centered on optimization and decision intelligence for the efficient operation of urban mobility and infrastructure systems. He has authored over 60 peer-reviewed publications and position papers spanning cyber physical systems, Internet of Things, mobile systems, and electric mobility. Dr. Mishra's contributions have been recognized through several prestigious honors. In 2017, he was named among MIT Technology Review's CR35 India Top 10 Innovators Under 35 and received the PCS Exemplary Contribution Award. He is also a recipient of the ERCIS Allen Benson and Marie Curie Fellowship for Scientific Excellence and Australian Government's Australian Leadership Award Scholarship. Recognition his leadership, potential, and societal impact. Beyond research, Dr. Mishra actively contributes to the broader scientific and policy ecosystem. He has served with professional organizations such as IEEE, ACM, and COMSNET, contributed to government agencies such as MIPE and engaged with standard bodies such as BIS and ISO. He currently serves as chair-elect of the IEEE Bangalore section, chair of the IEEE Industry Applications Society Bangalore chapter, and is a member of COMSNET Association and the ACM India membership and chapters committee. I would like to request beloved HOD, Dr. M. Prem Kumar, to welcome the keynote speaker presenting the subject as a token of respect. On behalf of the organizing committee, ICISE 2025, I invite Dr. Prashant Mishra to take over the session.
Hello, good afternoon. don't see any interest at all. Sometimes when you call something else, you are talking about something. And if you think that it all goes sleep. So we promise if you not sleep, then I'll give the call. So you want to sleep or not sleep? Half sleep. Okay, will not take too much of your time. I'm sorry for the delay, it's a technical glitch here. But I'll probably take you through this topic of decision making. Okay, and I will talk about the topic of decision making with respect to electric vehicles and electric mobility. Does this topic interest you? Decision making, electric vehicles, electric mobility, does this topic interest you? Moderately, little bit. What if I say that the topic is AI ML for electric mobility? That interests you? Okay, we talk about AI ML for electric mobility. So is this something very popular with you? Have you studied Pillar? Now you talk in the back, I cannot talk, right? All of you be quiet. And can you just spread out two of you on the center? Two of you come to the center here. Yeah, that's better. Okay, so I will talk about electric vehicles and electric mobility. Okay, so I think this is a slide to set a bit of the context. So when you talk about electric vehicles, essentially, so it is a vehicle that has a battery, and that battery is used to drive the vehicle around, right? You are smiling, is it right? Is it right? Is that a definition it be? Okay. So what I'm showing here is essentially the energy flow of the energy flow. Essentially, what is your left side is the source of energy. Okay, that is the energy is produced, and on the right hand side is the load point. That is where energy is consumed. So in this case, the load point is here the electric vehicle. Right? Now, to charge the electric vehicle, you have a battery there, and the battery stores energy. Right? So the question to ask is that where do you get that energy from? So the energy comes from the left hand side, which is the source point. You could get energy from a power plant, you could get energy from a renewable source, so on and so forth. Okay, and now you have that we call as the charging infrastructure. Okay, which means that this particular system would take energy from the left hand side, which is from the source point, and give it to the load point, right? That is where the energy flow will happen, right? And you can also think of doing it the reverse way, where you can take energy from the Indian also give it back to the source point, but that will come later. So the point of giving this context is that this is how the energy ecosystem is designed, where you have a place where you give energy and have a bunch of load points. And in this specific context, we are talking about electric vehicles at the load point. Okay, and there are multiple challenges that I have listed here. So if you look at it, on the source point, I have listed out the real challenges that essentially when you generate energy, the price of buying energy varies in the time of the day or time of the year. For vehicles, I'm losing the thing. Is that better now? So if you start smiling back and get distracted, so be very quiet and pay attention. Okay. So what I was saying is that when you talk on the left hand side, the key issues on the power generation point of view is that yes, we will generate power, but the challenge also comes by decision making of the pricing point of view. So when I am generating power and I have to buy power, the price of power varies depending on the time of the day or the time of the year. Okay. Similarly, when you talk about the right hand side, which is the electric vehicles, the depending upon the configuration of the vehicle, the type of the vehicle, the model of the vehicle, battery capacity will vary, and that leads to different vehicles with different ranges. Okay, And then when you talk about the charging ecosystem, you have charging various kinds of charging points. You have AC charging points, you have VC charging points, they follow different charging protocols, different standards, different power ratings. So essentially, if I am an operator, if I am let's say a fleet manager, if I am a charging operator manager, I have a lot of choices. So if you look at the left hand side, I have multiple choices in terms of when should I buy the power, at what price should I buy the power, am I going to make money, or is it cost effective or not? Similarly, when it comes to the charging point of view, there are multiple options, multiple kinds of charges, and similarly from a vehicle point of view, multiple kinds of vehicles. So as a decision maker, I am flooded with multiple options, and as a decision maker, my difficulty is to figure out what is the best decision I should take so that I can maximize a value function. The value function could be that I will maximize the profit, I can maximize my revenue, so on. Now that doesn't work. Now, when you look at the, so essentially, if I go customers to the previous slide, so what are the kind of operators you need in the ecosystem? So the operators would be typically the utility companies that generate power, okay, and sell power, okay. Then you have the charging station manufacturers, you have the manufacturers of vehicles, and you have the operators who manage the charging points, and the operators who manage the fleet. So you have multiple kinds of operators. Now the question to ask is that if I am an operator who wants to use electric vehicles, so what are the challenges? Let's say I have a big basket, I am Amazon, okay? I am delivering books to your doorstep, okay? And I typically have let's say 100 vehicles in my fleet, and all the vehicles are non-EV vehicles. Now, how do you convince our Amazon fleet operator or big basket fleet operator that it is good for you to transition from a non-EV fleet to EV fleet? Now, to convince him, you need to answer a few questions to him. Okay. So this person will tell you that when I run the business operations, I run two shifts. My first shift starts at 6 in the morning. My vehicles probably will go in this particular route, 6 to 30 drops of packages. It will come back to depot by 1 p.m. and again it will take a break of 1 hour. And then again it will go from the depot to again to the depot, come back to the depot by 10 in the night. Okay. So he said, so the first question is that, see, this is my business usual. My task is to deliver packages to the doorstep of a customer. It doesn't matter if I'm using anything or not, as long as I don't lose my business resilience, I'm okay to transition. Now the question to ask is that if let's say Amazon operator buys typically 10 EVs, the first question is that when to charge, how much to charge, and how fast to charge, so that all these vehicles in the fleet are ready with the right amount of charge for leaving at the right amount of time. Remember that I shared there are two shifts in a day. One shift at 6 in the morning and one at 2 in the evening. Wow. Okay. So before they leave for the deliveries, the vehicle should be fully charged. So that's the first question the operator will ask. Is it making sense? Don't think that is making sense. See, this is not a class, this is not a lecture. Okay, it's just a talk. Just pay attention. Now the second point is, now let's say I am a Big fleet manager, okay, and I have bought let's say 180 vehicles, okay. Now when I buy 180 vehicles, I also have to buy the charges with them because it takes a lot of time to charge the vehicles. Okay? Now buying the charger for the vehicle is also very costly. So what I can say is that I will not buy the chargers, I will probably use the public charger infrastructure. So whatever the charges I will in the city, I will just use that for my operations. Okay. Now the benefit is that I am not paying money for buying the charger, which is very good. But the demerit is that I now have to compete with the rest of the city for those charging spots. Now the question was that how do I ensure that I am able to do time delivery while competing with others in super charging spots. Okay, so how do I provide this delivery? So that's the next question. So next question operator asks is that tell me how do I find a available charging spot when I need it? When other people are also competing for the same resource. Okay, so that's the next question. Third question is that the operator may say that well, I cannot take so much of big on my business. I probably buy charging stations, even if they are higher cost, I install them in my depot. So the third picture is that associated with the 8 to 9 hours duration. So on a day, around 16 to 18 hours, the vehicles are on the road. So the 16 to 18 hours, the vehicles are on the road, the chargers are sitting ideal, which means that I have spent 6 lakhs in buying a charger, but in a 24-hour basis, 8 hours, I can't use that charger. And if I cannot use that charger, I cannot recover my investment from it. Okay. So the third question operator will ask you is that how do I convert this infrastructure that I have invested money putting it to have make profit out of it? Okay, how will I invest from my charger? So these are the first 3 questions. Anybody will ask you or ask the information transition to a related vehicle ecosystem. So the fourth use case under the essentially business use case, wherein given that the EVs carry batteries are basically a store of energy, right? Now, of course, we use the energy batteries to drive around. Think of scenario where you can actually use the energy batteries and also sell it back to the grid. So what we say is that can I use the same regular vehicle which has a battery to actually drive around and do the regular packages, as well as at an opposite time, and I go back to the discharging station and sell the energy back to the grid. So if I do that, I can also make money by selling energy back to the grid. Okay. So this both use cases is essentially a little bit futuristic, but much is quite doable, where you not only deliver goods, but also you sell energy on the go. Okay. And finally, this final picture here. So typically, when a transition journey happens, so let's say I have 100 non-electric vehicles. Just because I have to go through electric vehicle ecosystem, it doesn't mean that I can remove all my old vehicles and buy 100 new vehicles. I don't do it that way because there's a lot of money that is required to buy new vehicles. Okay. So what the business strategy is essentially, I will probably retire 10% of my vehicles and buy 10% new vehicles, which means that if I have 100 vehicles in my fleet, probably 10 vehicles I will retire and buy 10 new electric vehicles. And so essentially, I will run what I call as a mixed fleet. So in that mixed fleet, I will have 90 non-electric vehicles and 10 electric vehicles. Over the 6 months, I will run that configuration for around 6 months, and then after 6 months, I will probably buy 10 electric vehicles. So essentially, what I'm operating is what I call as a mixed fleet. A fleet that has both electric vehicles and non-electric vehicles. And that becomes a very difficult question because you have 2 kinds of vehicles. Each vehicle has their own characteristics, constraints, requirements, and it's all to work with that would run a business. Okay. So these are some of the regular topics. See, don't distract me. If you're not interested, please walk out. If you want to walk out, please walk out. I will take it and sit down. I manage such students every day. So, to summarize what I said in this point of time, so if you look at all these business questions, you can summarize these business questions or business challenges into 4 key points from a research point of view. So, what are these 4 key points? The decision making in this case is complex because, first of all, the scale of operation is very large. So, here I am not working with 10 vehicles or 5 vehicles, I am working with hundreds of vehicles. Okay. So, if you go to an Amazon depot, there are like 100, 200 vehicles in the depot. If you work with a FedEx or Flipkart, FedEx or DHL, they have 10,000 vehicles in the depot. Okay. So, the question to ask is that how to make decisions for 10,000 vehicles in one go? Very difficult question, problem to solve. Second point is you are dealing with a system that is highly heterogeneous because you have vehicles of different kinds, different models, different configurations. You have charging stations for different configurations, different power ratings. So you essentially have multiple options. Okay, and when you have multiple options, even though options are better, taking decisions becomes harder. Okay. Third point is that when you're dealing with physical systems, you are dealing with an environment that is inherently very uncertain. I say that well, this vehicle one will go on this route, starting point is this location, any point like that location, then will probably take 8 hours to go from location A to location B. But while the vehicle starts, it will be driving, the vehicle may take down or something could have happened to the road, and it cannot reach or integrate in the required 8 hours. So you are dealing with essentially a very dynamic and a very uncertain system. So when you are making decisions, you have to account for the uncertainty, and that makes the problem harder. Fourth point is, these decisions you don't have the entire time in the world to make a decision. For example, if you are on the road and you have to take a detour, you cannot wait for 1 hour for the decision system tell you that if you take electron here and not goes gate, right? You need that decision instantly, right? So what I'm saying is that all the decisions are very, very time bounded. Okay. You need the decision within the next 1 hour, the next 2 hours, the next 30 minutes. If the decision comes out in 1 day, then that decision is of no use to you. So all these 4 points actually make the decision making very hard. And if you relax one or more things, it might become a little easier. For example, if you say that we have a lot of flexibility in taking a decision, it will take 2 days to come out with a decision, then it becomes easier problem. But if I tell you that you will take a decision in the next 5 minutes, a very hard problem to solve. So what I just to summarize what I said, out of the 4 or 5 use cases I have presented to you in business sense, if you translate them into a research question, these are the 4 key technical challenges because of which the problem of decision making becomes very, very, very hard. Okay? Should I proceed? So I will talk about 1 or 2 use cases and some concrete computer examples. So the first example I will talk with respect to building an engineering. So let's say we are in BSc campus and probably this campus is 100 buildings. So as a building operator, my KPI is to manage the energy requirement of the entire campus. So just to put it in a systems way or visual way. So this is how the setup would be. Okay. So let's say in between I am a building operator for Sarah. Okay. And my KPI is that I buy 100 units of power on the grid and every day, and I have to make sure that I run all the buildings within those 100 units. If I cross 100 units and I probably draw 110 units, I will heavily penalize for the extra time. So as a building manager, my KPI is make sure that I operate all the operations of the building within those given 100 units. Okay. Now in a building facility, the load that takes the high, the system that takes the highest load or the highest power is the heating and cooling system. For example, the same building and there's the AC is going on, right? Cold air is blown on. Okay. So the colder current is warm air is blowing, right? So that is what we call the heating, ventilation, and cooling system. So that is the most power moving system in a building. And if you look at temperature, it will consume close to 50 to 60% of a building power source. Okay, so that's the most dominant power prime source in the building operator. So building operators, before the advent of EEE-DSCE, were very comfortable managing system. They had mastered how to manage this load and yet not cross the threshold of 100 units. Okay. Now what has happened is that here comes electric vehicles and the chargers. So for example, when you come in the morning, let's say you come in your EV, okay? As you come, you will park your car and put them to charge. And as the day progresses, as more and more people come on the campus, they park the charge, the charging load also goes up. We see that the load on the right side will also peak. And at the same time, as more and more people walk to the campus or in the auditorium, the system will start pushing more and more towards the air, which means the power will also rise. Okay. So now this is a very tricky question for building manager because this guy now has to operate both his dominant loads, yet respecting the 100 units threshold per day. So he just has 100 units to use in a day. And in those 100 units, he has to somehow manage both these loads which are very dominant loads. One load 40%, 50% of the entire power consumption, another close to 25% of the power consumption. Okay. Others like electric slides are very small compared to this two major loads. Okay. And the interesting part and the difficult part is that you cannot separate this two because as more and more people walk in, let's say 9 to 10 a.m., let's say in this room, there are probably 10 people. So the system would recognize that there are 10 people in the room, it will probably push colder air, cold air based on that fact that 10 people in the room. So power drop would be less. And let's say all these 10 people are EVs, they have covered 100 people, so let's say only 3 charges are EVs. However, between 10 to 12, let's say another 100 people have covered the campus. Okay, and all are secret. So because there are 100 people in the room, the cooling system will jack up the cooling air. Okay, so no power drop. And this people is already putting the daily charging. So which means the load of charging set was on 1. So what I'm saying is that both the source actually overlap in time. Okay. It's very difficult to spatially or temporally separate these two. And that makes the life of a building manager very difficult. Now, here's the idea that we want to explore. Okay. So the idea is here is that Anyways, EVs have batteries. Okay, and when let's say you and me, if we have batteries, we probably will come at let's say 9 in the morning and leave the factor by let's say 5 to 8. So my vehicle, and when I come in, let's say my vehicle has 50% charge, and my expectation is that by the time I leave at 6 in the evening or 5 in the evening, I get my charge goes from 50% to 80%. That's it. So the entire day the vehicles are parked in the parking lot. And the expectation is that by the time I leave the premises, I get my required charge at 50% to 80%. The idea is that if these vehicles are actually parked in the parking lot and I'm not using it, can I take power or energy from the right hand side, which is the battery of the vehicle, and give it for HVAC operations? For that period, when I believe it is going to cross the threshold of power. Okay. So these are the short bursts, 15-minute bursts, but of those 15 minutes, I will probably exceed the sanctioned capacity of the grid. So what I will otherwise want to do is that rather than exceeding my sanctioned capacity, why can't I take power from the EV side and give it to the HVAC side operation? Is this idea clear to you? So what we are saying is here is that given that both the stores are very dominant nodes and they overlap in time, at peak demand, I will run into a situation or I will run into a situation wherein I can exceed the sanctioned power limit for the day. If I sanction power limit 100 units per day, it may happen that I may end up using 130 units. And the grid operator will utilize the revenue for the extra 20 units. So rather than that, the idea is that rather than drawing that extra power from the grid, why can't I take power from the regular side, which is the battery of the EVs, and use that for HVAC operations? Of course, that won't happen when you have just one vehicle or two vehicles in a campus. So let's say 100 vehicles in campus. So you look at our next one, it's a 30 kilowatt battery. 30 kilowatt 100 vehicles and you will go to LED. So it's sizable. You can actually draw power for a small amount of time and use it for running operations. That's the key idea. So now, so the problem statement that we want to solve here is how do I minimize the building energy cost through jointly controlling the EV charging and HVAC? Okay, vehicle to building supply. So what I want to do is that the research problem for the building operator is that, or the key options question for the building operator is that how do I minimize my energy consumption, energy cost for the building by jointly controlling both slopes while allowing for this discharge operation for the vehicle in the HVAC. Now, what are the ways we could probably achieve this? What are the different algorithms? Of course, there are the very simple rule-based algorithms where you can say that if there are 10 people in your room, maybe you cool the room by this percent. If there are 20 people in the room, you cool the room by this percent. That's simple rules. Or let's say the vehicle requires this amount of charge, you just push charge at this rate. So I can use some very simple rules. So while these simple rules are very easy to implement, they are highly non-optimal or very far optimal. Okay. So even though, so let's say my optimal point would be, so essentially my optimal threshold is, let's say I should set the HVAC to 20 degree and my EV charging rate to let's say 10 amps. These rules may give you a value that are way away from this optimal values. Okay. Why? They are very simple to implement. The other side we have what we call as model predictive control, wherein these are more very sophisticated algorithms, wherein for running a model control predictive algorithm, you need the entire model system. Okay. And if you have the entire model system, you can then predict saying that if the current state of my system at 10 AM is this, and my future state, and this is what my future state should look like, what should the decisions I should take now? Okay, so you can predict the future and take the decisions now. Okay. So very sophisticated algorithms. However, very completely intensive. While they give you the best results, they will take a very long amount of time to do that results. Okay. So what have we come up with? So we have come up with what we call as a ML-driven technique for doing this joint controls. So we use this technique called reinforcement learning, and the specific instance of reinforcement learning is a multi-agent reinforcement learning for joint control. Okay. This is basically an ML technique. It's a data-driven ML technique for control problems, solving control problems. Okay. So of course I will not spend time on the. I will show you some interesting results here. Okay. So if you're very attentive, you will see the difference. Okay. So look at the left side. So the top plot is basically the price. It's the top plot. That's the price. Say that from 12 to 4 p.m. the prices are highest. Then the next plot is the air temperature. Okay. So the plot on top, the black bar is essentially outside air temperature, and the bar below is basically the internal room temperature. Okay. So what it says is that when the outside temperature is high, the HVAC is actually cooling. So you see these two short notches there. Let me just so if you look at this, so essentially this is the outside temperature, okay, which means that as the day rises, the temperature outside makes sense. And for that, the HVAC basically starts cooling. So there are two big cooling peaks at around 8 in the morning and around 12. Okay, these are peak sessions. And when it is cooling aggressively, the power drawn on the HVAC side is very high. You see these two big peaks when it starts pre-cooling. Okay. And of course, and this is the charging of the electric vehicles. So there are like 5 vehicles here and they are charging. So all these blue bars are charging costs. Here we are not doing vehicle to building. We are not taking power from the vehicle and giving the building. Okay. However, in this case, we are actually we are taking power from the unit side and giving the building. So what has changed now? Everything is the same configurations. Okay. However, here we find the electric vehicle which actually is staying there for a longer amount of time, which actually is it came probably at 10 in the morning and by 12 it was charged and it was staying till the end of the day. So what you could potentially do is that you can actually discharge the battery of this vehicle to some extent and you will push this power to power the HVAC. So what you can see is that when you do this, the power drawn from the HVAC from the grid is almost nil because you see this difference. When you don't do that, you are actually drawing power from the grid. Here you are actually not drawing power from the grid. Okay, and the corresponding graph here you can see you are actually discharging the batteries of vehicles. So this is what is going on. Now how does that translate into results? Now, this is a very important comparison. So here, this is the simple rule-based algorithms. They are the highest are optimal, but very fast. Okay. Rule-based algorithms, which I call as baseline one. Now, baseline two is what I call as the classical approach, classical control approach. But here I am not doing power transfer. So here, what I see that this blue bar is the cost, the accuracy of my solution. Okay, and the yellow and the orange bar is the runtime, compute time. So what I can see is that the accuracy solution is way better than this baseline one. And it does take a longer amount of time to compute that solution. Okay. And then I have baseline 2 where I will run the same classical approach, but I am now taking power from the vehicle and giving to the HVAC. Now, the accuracy of the solution, the quality of the solution is even more better. Let's do that. However, the computation time is probably 86 compared to what baseline 1 takes. So it takes a very long amount of time to give you a solution, even though it's very accurate. And this is this ML-driven or data-driven control technique, where the accuracy solution is probably not as good as the right? Probably 60% worse than the accuracy. But if you look at the runtime, it is extremely fast. This used to take 86x compared to the baseline one. This is as good as baseline one. So what it says that if you are willing to take a bit of think of the accuracy solution, you can actually get an algorithm that is extremely fast. Now, how do you use it? Here I'm trying to do a little bit of scale analysis. Here on the Excel side, a number of vehicles, number of EVs. Okay, it goes from 5 to 100, which means the scale system is rising. And 60 minutes is my decision time step, which means that every 60 minutes I will take a control decision. Should I probably change the room temperature? Should I probably what should the charging current I should put my chargers and so on so forth. And this blue line is my MPC, which is my baseline fee, which is the best algorithm that I can have. Okay. And this yellow one is my ML-driven algorithm. Okay. So as you can see, till around 75 vehicles, yes, as the number of EV in the system goes up, MPC or baseline fee starts taking more time, but it is still below the decision time of 60 minutes, which means that as long as it is able to give me a result within 60 minutes, I can use that result. I can live with it. Okay. However, beyond 75 minutes, it actually gives me a decision after 60 minutes. It probably gives me a decision in probably 75 minutes. Whereas I have to take a decision every 60 minutes. So at that point, this algorithm becomes no use to me. Okay. So there, what I can do is that I can now use my event-driven control algorithm. Okay. So what the argument is that, so if you look at the event-driven algorithm, it is actually fast and it scales very nicely with the neural system. Okay. So what we are arguing here is that we are not claiming here is that this event-driven algorithm is better than the classical approach, because classical approach is more accurate. But at a very large scale, the time taken by a classical algorithm is way longer to compute an optimal decision point. And that is where I think this event-driven technique can become useful, and you can probably design a hybrid of that. So forget about all of those things. So just to wrap up a couple of more use cases. So this is one use case where you probably use such a system for last mile delivery purposes. Okay. Just so it's produced. So this is a classical, let's say, Amazon or a big bus use case, wherein in a depot there are multiple number of EVs, and there are these delivery locations. So let's say these orange locations are where you want to deliver packages, and these green locations are where you want to sell your anything. Okay. So the question to ask is that how, as a fleet operator, I plan my entire journey so that I'm able to deliver my packages at the locations at the right amount of time, and within that schedule, find a good time to go to the destination. Again, what we have shown here is that there are a lot of classical techniques that work really well, but a very last case was calling for 10,000 vehicles per go. Event-driven control techniques give an edge to that one, but they're not as accurate as classical techniques. And just to wrap up, this is a typical use case of what we call as enterprise level education. Okay. So what happens here? Here, if you look at it, this is a large enterprise. So enterprise would mean the entire DSC campus. Okay. This is a large. And so entire campus may want to buy energy from different sources, not only from the grid, but from the energy market. We may have some battery on campus. And then you will be running your own shuttle services, bus services, and so on. Okay. And they may go to different locations, come back, and do these things. So the question to ask is that how do I actually find a sweet spot of actually knowing how much power to buy from which source and still run an operate? Because different sources will give you power of different quality and different price points. Okay. And then you have to run these operations with those things. So the question asks that how do I run my entire enterprise operations, which means all my buildings, all my lifts, all my lights, and yet figure out a good decision as to at what point in time should I buy power from which source and at what price point. And again, what we have shown here is that there are the classical techniques. You can model this problem classically. Who's talking? So you can model this problem classically, but again, it will give you very accurate solution, but will not scale. And it will use some form of approximation techniques. Here we have the mixture approximation techniques that we call as. So we have used this approximation algorithm called Karuna Herd Unity Optimizer, essentially for meta-heuristics. And the second meta-heuristic that we use here is the genetic algorithm. And with the combination of both of them, we are able to derive a system that was extremely fast, yes, with a little bit of figure of the accuracy. Okay. So I just summarize what I've spoken at this point of time. So ideally, if I had a long amount of time, I will probably, this is a lecture for 1.5 hours basically. So the first question that I covered was this question of building energy management, where we typically discuss a bit about how and classical techniques like APC do, and how this learning to optimize technique using ML and AI can actually do the same operations, which is not as accurate as classical technique, but are very fast. The second question that we touched upon is this question of how to do last mile delivery operations, like what the Amazon do. And then again, the problem over there is that we have a lot of classical algorithms, very accurate algorithms, but they don't scale as number of vehicles grow. So how do I find a solution? So there also we have shown that the learning to optimize technique that will give you a solution very large scale. Yet you have to take it into the accuracy. And the third question that I touched upon is the enterprise management, wherein it was basically a combination of finding two kinds of decisions. Well, the first decision was a rocket decision. The second decision was a power decision, and they again showed that if you can model the system well and write a mathematical program, you will get the most accurate results. However, again, it doesn't scale well. So here again, you could use some approximation techniques to actually give you that scale that you require. So with this, I will stop. I'm sure you have no questions at all. But if you have, please come forward and pose the question. But this was the talk. I am sorry I rushed a bit, but that is it. Thank you very much. Lastly, guys, ask some questions. Any questions? No questions? No questions? Not one? If you don't have a question, I ask you a question. Do you have a question? Yes, no, what? Okay. Any other? Yes. No, I think this is the classical maybe comment that has come in. Okay. So the way to definitely say that we should ask that we cannot just propose a meta for sake of it. Meta heuristic is an approximate technique. And when you need approximate techniques, you need approximate techniques where you cannot solve the problem in a classical manner. If your classical algorithm can solve the problem, then nothing can make it. So you can only correct the reviewer by showing that you have got the problem in a classical way. You have written a nice mathematical program for it. And you show that this mathematical program probably doesn't give you a solution with the right amount of time that you require, or doesn't give a solution with the right amount of assets that you require. For example, the question, I have to solve for let's say 1,000 matrix. So in all of these, I have a classical model. And in those classical models, I was able to show that it only goes give the solution for 10 matrix. Beyond that, these are areas that you have problems. They take days to give a solution. Okay. And that's when we motivate the need for a approximate algorithm. And once we motivate that by concrete numbers, then the motivation user evaluation will make sense. And that's where I think a lot of comments come. So a lot of many times we try and algorithm because we want to try algorithm. But if you just show the motivation for the need for algorithm, then it becomes very achievable to you. So that's also I think that I have tried this classical approach, and this is my limitation of classical approach. And to overcome the limitations, I have this method. No, it is not failing, it is taking longer time. Yes. Yes, ADC is basically as I said, this is a classical control technique, and it is solved the problem that is well result. Okay, so you that I say that if the current state is this, and my entire time horizon is let's say 12 hours, I will solve for 12 hours. That's the receipt horizon term, right? So you can imagine if you're computing the receipt horizon manner, the time you compute is actually longer by design is longer. And the search phase, so essentially if you solve for let's say 5 vehicles, it's a very small search phase to move over the IPC. Even if you do the design receipt horizon manner. But if you solve for 1,000 vehicles, the search phase is huge. And since the classical techniques, they actually do a very precise job of solving at each point. So what we have shown the result is that we are not debating on the accuracy. The accuracy is the best. Nobody can beat the accuracy. What we are showing here is that as the system scales from 5 vehicles to 100 vehicles, MPC takes a very long time to give you a result. And then you quantified for longer time. So we have shown that at next when you are trying to compute some 100 vehicles, it takes around 75 minutes to complete it. Whereas the addition time time was 60 minutes. So in that case, it is not no use to me. Because my decision time, I am within the decision clock is 3 minutes, but everything is giving a result at 10 minutes. So I can't use that. That is justification. I just small number of constraints, sir. This is a very small number. So essentially, you have a formal method availability. It is objective point, you have bundle constraints. You write a math program to solve it. Only the input space will will change. Your input parameter will change. So input rather having 5 vehicles, there are 100 input parameter 100 vehicles. See, end of the day, classical model is what it is basically objective functions and a bunch of constraints. And it is not parameterized. So if the system has 5 vehicles, you feed the input of 5 vehicles. System 100 vehicles, feed the input of 100 vehicles. Why kind of optimize? Is that the search space increases? Yeah. Yeah, that's it. So reinforcement learning is a data-driven technique, which means that it needs to be given data of prior policies. So let's say I am building out a building and I am running it for 6 months. So I have a data for it. So if you give the data to a RL algorithm or design a method for it, it will be able to first of all interpret how good the existing policy was and use that to also come up with some newer policies. So I made a point now is that how does RL learn? The basis of any embedded technique is data. If you have data with you, if you give the algorithm, it will be able to pick up patterns from that data. And RL is basically a little more sophisticated than a simple prediction model, so it becomes a positive structure. But without data, you cannot run any embedded technique. Without data, no scope. Is it making sense? Questions? Okay, let's say you come to the university and you're parking, and you're saying that I will not give my car for charging, use this charging. So what if I would say that so you don't pay for the charging? Obviously, DSCE you told me. No, will you pay for the charging or free for it? Let's get charge. So let's say I tell you that I'll waive your charge. You can charge the entire day how much more I will not take any charge money from. But instead I will use your battery. Will you do that? Yeah. So the point is that there is a flexible system. So you come, let's say 10 in the morning, and you have a vehicle giving at 4 your class is 10. I know you can. So your vehicle is parked around 6 hours. Your requirement is that you come in the morning at 10 and you leave at 4. By the time you leave, this is the amount of charge you want. You don't think that I want charge next 1 hour. If you give the requirement, I cannot give away. However, if you typically are there the entire day, I can probably charge this charge. And as long as I give I don't charge, by the time you go and put in, you should be good. How long you calculate? So you have a car of 30 kilowatt, you have not fixed 30 kilowatt. Okay. You are associated 50% 30 kilowatt. And I use it into charger of amperes. How long will it take? Take time for you to go. Normally, a full charge at a standard 8 to 18 is 1.5 hours. But compared to 50% charge, it becomes 40%. This is not a slow charge. Anything else? I still need one last question last day. I'm not even thinking about that. You ask the question. Let me ask this question. One question. See, in my college, I was a ranking master, okay, 20 years back. Nobody will escape me. One question for me. Be smart. No question. Not even one. No question. Okay, go ahead. Very good question. Okay, so the question the gentleman is asking is that, see, you are doing a circuit or charge discharge, but then you are doing a battery. You probably slightly will defeat. Okay. Now, think about the economics. Okay. So battery is a energy asset, and manufacturer will give you a time that this battery, if you run for with regular operation, will last for 7 years. Okay. Now the question to ask is that, do you keep a car for 7 years or a phone for 7 years? Might, okay, very good. You might. Secondly, let's say let's say the cost of battery is, let's say, 3 lakhs. And by doing this charging strategy, you have probably earned 4 lakhs. Have you recovered the cost of the battery? Then why do you care? So every day with this charging strategy, I'm giving you benefit, I'm not taking it for free. I'm giving you some benefit. So if the cost of the battery was, let's say, next one cost 15 lakhs on road, out of 7 lakhs of battery. And I have through this charging for 3 years, you have probably recovered 8 lakhs. So better getting battery. So think of an asset. Why that's not a very good question, because it all ties back to the cycle effect and sustainability, anything that can be argued again. But what I'm saying, economic sense point of view, you can argue it in a certain way. See, every day your phone, the phone also has a battery, but none of us we use our phone more than 2 years. That's why you look at it, the manufacturer is very smart. See, in the third year, your phone battery burst out. Okay. So everybody's people, they are design system based on user behavior. If you are a person or we as a community or people used to probably use the phone for 10 years, then the phones or the battery of the phone is much more robust. Just because we use it for less than 2 years, they design a phone battery for 3 years. Yes, battery is meant for that. It is basically energy storage. You can push. So these are, yeah, so essentially there are norms for charging, saying that it shouldn't do a deep discharge or a deep charge. Okay, you should probably charge in 80 degrees. So recommended that you should probably discharge less than 10%. So so let's say or charge more than 80%. So if you follow those guidelines, it will give a good lifetime. That is, it's not encouraging to have a low full charge. It's encouraging to charge 80%. And when you discharge, not go below 20% or 10%. Okay, that's a nice option range of it. Are we done with all the things? But still nothing for your sake. I think you remember me after this class. A huge gap, sir. What I want to say that is stick on the iceberg. Okay. See, essentially, hardware wise, lot of it. See, there's a huge scope for pattern improvement. Okay. But that requires someone to do deep tech. Okay. Then product development, I can see. Now, even the biggest challenge is the packaging. Okay. New chemicals, new properties, lot of controls. Okay. New packaging. Okay. Our packaging that long lasting doesn't catch that. That is product model. Okay. How to build a vehicle, we are good at it. How to build a battery, we are not good at it. That is the key point. Secondly, when you look at, see, cars don't work inside, they work as an ecosystem. Okay. You use vehicles for doing fulfilling a purpose. It could be business purpose or personal purpose. Which means that a vehicle has to cut across parking, charging, payment, food, building. So look at life. So tomorrow morning left home, you probably drove your home to campus, from there you go some other place, from there you go some other place, you find a park, you find a charging. So a vehicle in the entire day cuts across different other forms of interaction. Now, which means that as an individual or a business, coming to the right decision is a very difficult job. We take ad hoc decisions or basically decisions which are very linguistic in sense. But those decisions may not be the most optimal. So when I run a business, see for me, asset business, logistic business is basically a very razor thin business. Okay. Even 5% of my assets would probably get into trade. So the question for me is that how do I make those very accurate, very precise decisions? So decision making, so there's a huge gap in decision making. And that's why I think we are trying to look at, so and saying so that there is a lot of work done in starting the process. You cannot beat it, there's so much time over there. Now where we're suffering currently is that the kind of scale we are reaching, we are not able to use classical algorithms for solving problems at that scale. So there's a huge area for that. And that makes a very interesting complex problem. These are all APR problems. So if you can come up with a decision engine that can give me a decision, a very accurate decision in a time-bound manner, nothing late. But saying so, there are a lot of players. So I don't know what everybody is doing that. We are basically, I don't think entrepreneurs build vehicles, scooters, and everything, but cars, the stand comes to do it. Okay. The current entrepreneurs in this market basically are the charger providers. They will let you discover the charger, do the payment, small things. Okay. And that itself is valuable. Well, I'm not saying it. But these are short, they won't survive for long because there's nothing deep about it. How difficult is it to discover the charger? Currently, because other not like you are probably a leader in that field. But it's very easy to do that. So I think if you're getting entrepreneurs, try some that little seat there. Otherwise, these are cutthroat competitions. Won't survive for 6 months. Level 1 funding will get level 2 done. Are you done with questions? You all look very scared, especially last row. No questions till now? Not an entrepreneurial question? Ask me, how do I build a startup? At least that question should come up. Nothing? What happened? Speak. Okay, fine. Let me answer. We talk happy people already.
Thank you, sir, for your insightful and thought-provoking address. We sincerely appreciate you taking the time to share your expertise and perspectives with us today. Your contribution has added great value to the conversation. Thank you.
Yeah.
Request all the participants to kindly take their seats. Good evening to one of our parents here. I am Akshaya, your host for this evening, and I extend a warm and cordial welcome to you all. Respected dignitaries, distinguished guests, faculty members, researchers, delegates, and dear students, welcome to the valedictory session of the third International Conference on Intelligent and Sustainable Power and Energy Systems, ICIS-PES 2025, organized by the Department of Electrical and Electronics Engineering, Diana Savage College of Engineering. To begin this valedictory session, we have a short video presentation highlighting the journey and memorable moments of ICIS-PES 2025. May I request the technical team to please play the video. Thank you. That was a wonderful glimpse into the conference proceedings. I'm sure everyone present here has had a truly enriching and memorable experience at the conference. May I request everyone to kindly rise as we welcome the dignitaries onto the dais. We have with us Dr. Prashant Mishra, Senior Scientist, Tata Consultancy Services Research and Chair-elect 2026, IEEE Bangalore Section. Dr. Suma V, Vice Principal, Dayanand Sagar College of Engineering. Dr. Prem Kumar M, HOD EEE-DSCE and Convener, ICIS PES 2025. Dr. Gopi Sethi Manikanta, ICIS PES 2025 Coordinator. Dr. Arjun Kumar JD, ICIS ISPES 2025 Coordinator, and Dr. Balamurugan M, ICIS PES 2025 Coordinator. Thank you. To invoke the divine blessings for wisdom, harmony, and success, I request Sakshi to lead us in a prayer.
सदा वसन्तं हृदयारविन्दे सदा वसन्तं हृदयारविन्दे भवं भवानी सहितं नमामि भवं भवानी सहितं नमामि कर्पूरगौरं करुणावतारं संसारसारं भुजगेन्द्रहारं कर्पूरगौरं करुणावतारं संसारसारं भुजगेन्द्रहारं मन्दारमाला कलितालकाले मन्दारमाला कलितालकाले कपालमाला कृतशेखराय कपालमाला कृतशेखराय दिव्याम्बराय च दिगम्बराय दिव्याम्बराय च दिगम्बराय नमः शिवाय च नमः शिवाय नमः शिवाय च नमः शिवाय कर्पूरगौरं करुणावतारं संसारसारं भुजगेन्द्रहारं कर्पूरगौरं करुणावतारं संसारसारं भुजगेन्द्रहारम्
Thank you for that sacred invocation. I now invite Dr. Arjun Kumar JD to deliver the welcome address.
Good evening, Dr. Dear. Respected chief guest, esteemed speaker, resource person, honorable chairman, vice chairman, chief secretary officer, respected principal, vice principal, and esteemed head of the department, and conference convener and coordinator, and dear faculty members, participants, and dear students. Ladies and gentlemen, a very warm and pleasant welcome to one and all present here for third international conference on intelligent sustainable for energy and power system ISPS 2006. It gives me immense pleasure and pride to welcome this other gathering as we have come together to conclude the intellectual, enriching, and academically essential conference. Over the past 2 days, we have witnessed insightful deliberations, thought-provoking sessions, technical sessions, and meaningful interactions that have truly fulfilled the objectives of this international forum. On behalf of our organizing committee and our institution, I extend cordial welcome to our respected Dr. Prashant Mishra, 2026, Itinerary Kind Session, Senior Technical Dr. Consultant Service, Researcher, visiting faculty in the Department of CPS, Indian Institute of Science, Bangalore, whose presence today had a great value and significance to the humanity session. We are deeply honored by your acceptance in our invitation. Welcome you, sir. I extend my hearty welcome to our management, our honorable vice chairman, vice chairman, secretary, joint secretary, and also principals in their absence here for their constant support, encouragement, and visionary leadership, without which the conference would not have been possible. I also warmly welcome our vice principal, Dr. Sumavi. Your valuable contributions, scholar insights, and active engagements have elevated the academic standard for this conference. Welcome you, ma'am. Head of the department, Dr. M. Kumar, for invaluable guidance, academic leadership, and continuous support that greatly contribute to the success of these international events. Welcome, you, sir. A special welcome to my fellow coordinators, Dr. Balumandan and Dr. Gopishiti Manikanta, whose tireful efforts and methodological planning ensure the smooth conduction of the international event. Welcome you all. I also welcome all the organizing committee members and student volunteer teams for their tireless effort in the successful conduction of the conference. My warm also goes to all the participants, research scholars, and the students. Your enthusiastic participation, paper presentation, and interaction discussion have made this conference vibrant and successful. Sessions that assist the knowledge shared, collaboration form, and ideas for during this conference, and carry forward into our academic and then professional journey. Once again, I extend a hearty welcome to everyone present here and wish the organizing function great success. Thank you.
Thank you, sir, for the warm and gracious welcome. We are honored to hear from Dr. Sumati, our respected Vice Principal, Dayanand Sagar College of Engineering. I kindly invite ma'am to address the gathering.
Good evening, my lord. Yesterday we were there to do the evaluation, and today I am here again to see that the validation happens. First and foremost, our deep appreciation and gratitude to Dr. Prashant Mishra, who is actually a backbone to the IEEE. He's doing so much towards IEEE being in the corporate world. Real big round of applause to him. The reason why we organize these types of conferences is not just to prove that we are doing excellently, but to get a lot of knowledge from the intellectuals who come here to deliver the talk. In fact, today's address presentation, what he gave was really excellent. So there's a lot of breakthrough ideas that you can work on, and also when we do all these types of activities, we gain confidence that we can make ourselves present in front of the audience and make the world to accept our ideas. That's the intention that we do all these conferences, and really we should congratulate for the true success of this conference, for the entire team of Dr. Prem Kumar and the department, the coordinators, conveners, student volunteers, competitors, as well as the people who have given good innovations of food committee. Everybody, right from the banner, we know how much of stress and pain will be there and the efforts that is put on. So, congratulations, a big congratulations to each of you, because this is a moment that you have to applaud to yourself and say, yes, it's me. We thought we can do, but Now you will say, yes, we did it. So keep doing such type of activities, and IEEE members are there because they are always showing their both hands to say, yes, we will, we will accept anything you come forward, and they are there to support us. Also, the industry is always there to say that we are there to help you with your ideas to get it curated, and you are here to pitch it. That's what sir was there to ask thinking. If you can, if you could have asked one single question of being an entrepreneur, what should you do to have a startup? What would you do? He would have been very happy to answer. But of course, we have e-summit coming up on Monday onwards, Monday, Tuesday, Wednesday. So you have a lot of opportunities where you can definitely go and ask each and every successful entrepreneurs, startup people to see how you can also be an employer apart from just being a researcher. So with this note, I'm sure you had a good time both the days and got a lot of knowledge from all the speakers, eminent speakers, intellectuals. Above all, 100% networking. This is what we expect from these conferences. And all the best to all of you. Thank you. Have a nice day. God bless you.
Thank you, ma'am, for those insightful words. Your words truly light up the room. It is a great honor to have Dr. Prashant Mishra as our chief guest this evening. Dr. Mishra is the Chair-elect 2026 of the IEEE Bangalore section, Senior Scientist at Tata Consultancy Services Research, and a visiting faculty in the Department of Cyber-Physical Systems at the Indian Institute of Sciences, Bangalore. I now invite him to kindly deliver his address.
I don't have much to say. I said what all I have to say. But just probably 2 to 3 additional points. See, I graduated from an undergraduate. I am a BE in computer science. I graduated in the year 2005, and there are 20 plus years since I graduated in GE program. And till now, when I wake up in the morning, there are 2 things that worries me. The first thing that worries me is that will I ever hire myself back? So I got placed then and there, and of course, went 5 studies, came back again, got into workforce. But till now, at this point of time, this is one, the first question that I asked myself is, will I ever hire myself back? The second question that worries me is that, how do I work with people who are smarter than me? If I look at all of you, given the advent of technology and the type of exposures that you all have, you are definitely much smarter than me. So there's no doubt about it. So the question that always bothers me, how do I work with people like you? One of the learnings that I have come across in my career is that so if you look at the tenor of this, or the journey of people who have served very long in social services, is that people have always learned beyond what they initially trained for. For example, I was undergraduate in computer science, but I always had a bent for doing intelligent research. So I have spent a lot of time working on embedded systems, power systems, and energy systems, because I believe that the real problem that computer science can solve is when the multidisciplinary aspects come, and that's where domain comes. So one of the things that I urge you to do is that be very good in your domain. Without domain, there's no problem solving, because problems actually come with domain. If you are a mechanical student, a engineering student, a civil student, make sure that you are very good in your domain and augment that in your professional. Okay. And I'll take a bit up from my childhood at one of the right. So I do a lot of high drive of these research myself. And kind of people that we hire, and so something I was giving a point of to Professor Kumar, the best talent that we have in the lab. So that are the people who actually are not from computer science background, they are from domain background. Okay. And I'll tell you another strong aspect, the statistics that I have is that people, in fact, do hire engineering graduates and also science graduates. And we better not in science graduates. Okay, and that is revealing to me because and relationship when there is always a lot of questions hired asked to us when we are hiring science graduates, especially people who do a BSc, MSc, and come and join us in the lab. But believe me, these are the guys who are very good in the subject area. They have learned it really well, and now they're able to programming well. So that's not anymore differentiated very easily. So the point is that please learn your topics very well. There are a lot of things to learn. Keep on exploring. Be good in what you study. If you're not good in what you study or what you learn, you are not good with anything. So please be very sure and put your attention and your heart to what you're studying. And there's a lot of options out there. Why we always hear that this is not happening, that has not happening options, AI is taking over, none of that kind. There is a lot of options out there. I think we don't find the right. So if you're the right person, I think the options are just lazy out there. So be motivated and be focused and work very hard. Okay. Thank you very much.
Thank you, sir, for your insightful and inspiring address. I now invite Dr. Gopisetti Manikanda to present the conference summary report.
Good afternoon to one and all. I extend a warm welcome to everyone present at this concluding session of our two-day international conference on intelligent and sustainable power and energy systems. It is a both pleasure and privilege to present the conference report. This summary seeks to capture the essence of our collective effort over the past 2 days by highlighting the key themes, insightful deliberations, and rich exchange of knowledge that have been defended this month. International Conference on Intelligent and Sustainable Power and Energy Systems is an annual conference series that was initiated in the year 2023 and present conference represents its third edition, encouraged by this growing interest and active participation from academia and industry. The conference series is envisioned to continue in the coming years as a sustained global platform for research, dissemination, and collaboration. The current edition of the conference was successfully conducted in hybrid mode, enabling participation from delegates across different geographical regions. The preparatory activities of this conference commenced in the month of March 2025, driven by the strong support and encouragement of our college management, principal, and under the able guidance of our beloved head of the department, Dr. M. Srin Kumar. Their constant motivation and our leadership played a pivotal role in shaping the conference, ensuring its successful execution. The conference served as a distinguished international forum for researchers, academicians, industry professionals, and students to deliberate on recent advancements, emerging challenges, and innovative solutions in the domain of intelligent and sustainable power and energy systems. ICIS 2025 was conceived with an objective of fostering interdisciplinary research and promoting global collaboration in the area of power systems, renewable energy, intelligent control, artificial intelligence application, and sustainable technology. The conference aligns strongly with global sustainability goals by encouraging research that support clean energy transition, smart infrastructure, and resilient power systems. ICIS 2025 covers a broad spectrum of contemporary research areas, including but not limited to intelligent control and automation, renewable and sustainable energy systems, smart grids, microgrids, and energy storages, power electronics and electric vehicles, AI and ML applications in power and energy systems, IoT for sustainable development, power system protection, control, and optimization. Special session IoT-driven energy management and microgrid innovation, organized by Dr. Raman Kumar M, Department of EC, Nagamada Reddy Engineering College, Hyderabad, India, and Dr. Rajendra Papala, School of Electrical and Communication Science, JSPM University, Maharashtra, India. The multidisciplinary nature of the conference facilitated in-depth technical deliberation and effective cross-domain knowledge exchange among participants from academia and industry. ICIS 2025 was supported by eminent professional bodies as technical partners, including IEEE Power and Energy Society, Institutes of Engineers India, IEEE Power Electronics Society, IEEE Industrial Application Society, and IEEE Vehicular Technological Society. The conference was ably supported by Logisa NextGen, a leading industry partner specializing in electric vehicles, robotics, and IoT applications. The publication partner for the conference includes E3S Web of Conference, Cypress, STM journals, ensuring wide dissemination and visibility of the accepted research contribution. The first call for paper was announced on 28 July 2025 and submissions were received steadily from the initial stage itself. To ensure a robust and fair evaluation process, a review panel comprising more than 400 professors, associate professors from reputed institutions in India and abroad were constituted. The review process follows a single blinded peer review methodology. More than 450 research and review papers were received from across India, representing states such as Karnataka, Andhra Pradesh, Tamil Nadu, Telangana, Punjab, Chhattisgarh, Haryana, Jharkhand, Uttar Pradesh. In addition, international submissions were received from USA, Russia, Uzbekistan, Ukraine, Kuwait, Oman, Saudi Arabia, Iraq, and Jordan, reflecting the global reach of the conference. Following plagiarism screening, a few papers were rejected due to unacceptable similarity levels. The remaining submissions were evaluated by two independent reviewers based on the review recommendation and authors' input. 92 papers were finally accepted for presentation. These accepted papers were further categorized into different publication tracks. Accordingly, 60 papers are being forwarded to E3S Web of Conference Corpus Index proceedings, 25 papers to Cypress proceedings, and 4 papers to Google Scholar Index STM Journal for potential publication. The technical session witnessed vibrant discussion, constructive feedback, and meaningful collaboration, interaction. Special initiatives such as Best Paper Award and Best End Researcher Award serves as a strong motivation for high quality research contribution. Overall, the conference successfully facilitated networking opportunities, encouraged future research collaborations, and further strengthened the industry and India interface. The inaugural function of the conference was raised by our esteemed guest, Dr. Srinivas Taravuthala, Professor, Department of EECS, Indian Institute of Science, Bangalore, and guest of honor, Dr. Ramesh Dharla, Assistant General Manager and Head, Power Team R&D, Panasonic India Private Limited, Bangalore. We also honor Dr. C. Bharati Rao, Center Head, Center of Mobility, SRM Institute of Science and Technology, Chennai. Along with them, our college principal, Dr. P.G. Prasad, Vice Principals, Dr. Ramaraj K., Dr. Sumari, and Mr. Guru Venkatesh, Chief Academic Officer and Head of the Department, Dr. Prem Kumar Yan, will also present at the inaugural session. For this valedictory function, we are fortunate to have Chief Guest Dr. Prashant Mishra, Chair 2026, IEEE Bangalore Section, Senior Scientist at Tata Consultancy Services Research, and Vice Principal Dr. Sumaru. One of the major highlights of ICIS 2025 was presence of eminent keynote speakers from globally reputed institutions and industry. The keynote address was delivered by Dr. Hassan Hayes, MIT, USA, Dr. Sheldon Williamson, Ontario Tech University, Canada, Dr. Prashant Mishra, Senior Scientist, TCS Research India, and Dr. Bharati Raj C, SRM Institute of Science and Technology, India. The keynote talks provide deep insight to the future power system, smart transportation and electrification, cyber-physical systems, and sustainable energy technologies, inspiring researchers and students. The conference featured a wide range of sessions and presentations covering various topics. In total, 12 sessions were conducted, and each session select one best paper award. Every session was chaired by two experts, one external, one internal member served as a session chair. To impact of this conference goes beyond these 2 days. We encourage all participants to take forward the knowledge, connection, and inspiration gained here and apply them to create positive changes in the respective fields. In conclusion, I would like to highlight the meaningful impact of this conference. It was a collective effort aimed at sharing knowledge, encouraging collaboration, and addressing important challenges. Thank you. Jai Hind.
Thank you, sir, for the comprehensive summary of the conference. We now proceed to the certificate distribution ceremony. May I request our chief guest, Dr. Prashant Mishra, to kindly present the certificates. Let us begin with the special session appreciation certificate. I request Dr. Rajendra Papula sir to kindly receive the certificate. Thank you, sir. I request Dr. Raman Kumar to kindly receive the certificate. Let us proceed with the Best Paper Award certificate. Paper ID 43, Priyanshu Tiwari. Paper ID 127, Jayashree Kundan. Paper ID 208, Hansika Venkatesh. Paper ID 137, Lokesh Madlaya. Paper ID 100, Srihari K. Paper ID 72, Ranilo Barroman. Paper ID 260, Dr. Kamala Narayanan. Paper ID 69, K. Aziz. Paper ID 199, Sevanti. Paper ID 334, Anand Kumar. Paper ID 188, Renushri HS. Paper ID 298, Vinay Kumar Brigade. Next, we move on to the presenter and participation certificates. Paper ID 196, Sahana Gowda and team. Paper ID 188, Renushri HS. Paper ID 310, Mohammed Sahal. Paper ID 199, Sevakti V. And team. Paper ID 298, Dilip Kumar DK. Paper ID 43, Priyanshu Tiwari. Paper ID 127, Jayashree Pudari. Paper ID 180, Yashaswini S. Paper ID 12, Trisha. Paper ID 208, Hansika Venkatesh. Paper ID 324, Varun Archal. Thank you all. Thank you, dignitaries. I now request Dr. Suma V to kindly present the certificates. I request Dr. Prem Kumar M, convener ICIS PES 2025, to receive the certificate. Request the website development committee to please receive your certificate. Request the sponsorship and promotion committee to please come on dais. Request the faculty and the student volunteers to kindly come on the dais. Request the registration and stage committee to please be on dais. Registration stage committee. Yeah. Requesting the review committee to kindly receive their certificates.
Very good.
Request the technical committee to kindly receive their certificates.
Hard to express.
Request the food and hospitality committee to receive their certificates.
John, next is yours.
John.
One second, can you go with left side, madam?
Requesting the publication committee to kindly receive their certificates.
John. John.
I request the finance committee to kindly receive their certificates. I request the media, news and documentation committee to kindly receive their certificates. Thank you all. Your continued collaborative support has added grace, efficiency, and excellence to ICIS PS 2020. We sincerely thank each one.
But you didn't work.
I kindly request Dr. Suma V, Vice Principal, DSE, to please come forward to present the moment. I invite I invite Dr. Prashant Mishra, our chief guest for the session, to grace the stage and share the honorable doctoral track.
Yeah,
I kindly request the chief guest to present the memento to Dr. Balamurugan M. Coordinator, ICIS TS 2025. I request the chief guest to kindly present the memento to Dr. Arjun Kumar GD, Coordinator, ICIS TS 2025. I request the chief guest to kindly present the memento to Dr. Gopisetti Manikanta, Coordinator, ICIS TS 2025. Thank you, sir. The room is now open for feedback. Request the participants to kindly give their valuable feedback. If anyone wishes to give a live feedback, we are welcome. To formally conclude this valedictory session, I invite Dr. Prem Kumar M, Convener, ICIS TS 2025, and Head of the Department, EEE, DSCE, to deliver the vote.
So the respected places, keynote speakers, honorable editors, reviewers, management, administrators, or students, faculty members. Very good evening to one another. Yes, so almost 9 months of our work is coming to the conclusion. So before I conclude formally, I would like to give a very big applause to all the coordinators in the organizing committee. Can you please give the big round of applause? When we planned this conference, we don't know that during this time the exam will be scheduled. So we thought because the fifth semester students they organize so that they have the experience, and seventh semester students also have the experience to conduct this kind of conference. And fortunately or unfortunately, the exam schedule came in that time. Then I just completely worried so what to do because the second year students they don't have any kind of experience. Last time how they were sitting like this, they were sitting during the conference, they just listen. And we started asking the people, can you volunteer this any of the committee? We don't really, more than 60 students are volunteers from second year. And this complete show was run only by the second year students. So, we have done a meticulous plan each and everything without any has gone. It's very nice. I thank each and everyone, including all the faculty members and the students. I thank each and everyone before I do response to the conclusion. So the first and foremost, on behalf of the organizing committee and the Department of Electrical and Electronics Engineering, I express my deepest gratitude
To all my chief guests and the guest of honors, Dr. Srinivas, Dr. Ramesh Darla, Dr. Prashant Mishra. So all your presence gave a very great value to this conference. So thank you all the guests and the guest of honors. And I would like to convey our sincere appreciation to our eminent keynote speakers, whose technical depth and global perspectives enrich the conference. Dr. Hasna Izarhelu from MIT University, and Dr. Sheldon Williamson, professor from Ontario University, Canada, Dr. Prashant Mishra from TCS, and Dr. C. Bharadiraja from SR Institute. And also, we extend our special thanks to foreign individuals for the EEE above conference. Dr. Fernando Inay, Faculty of Engineering from Universidad Finisterre, from Chile. We are equally grateful to all the internal editors also for this particular edition, and the reviewers, the technical program committee members for their rigorous evaluation, academic integrity, and timely support which ensure the high quality of the publications as ICASPS 2025. And our heartfelt thanks to the special session organizer. So they organized the session in the team of IoT-driven energy management and microgrid innovations. Dr. Raman Kumar and Dr. Rajendra for organizing this session. Thank you, sir. Thanks for joining. So we also sincerely thank all the session chairs, as we told you already, and summary before. We have organized 12 panel sessions. So in that each panel session had 2 session chairs, both internal and external. So we invited 24 session chairs from various institutions and organizations and I just want to thank them for their efficiently conducting the technical sessions and facilitating high quality scholarly sessions. A very special thanks to all the researchers and authors who participated online and offline both and shared their valuable research contributions. And as you all know that you are the backbone for this event, so without which we cannot make this kind of successful conference. So thank you all. And I respectfully acknowledge and thank our management, the chairman, vice chairman, joint secretaries and secretary, and also our principal, Dr. B.G. Prasad, and our respective vice principals, Dr. Ramarajan, Dr. Sumavi, Dr. Ramesh Babu, and all the deans, head of various departments, and also the chief academic officers. And we gratefully acknowledge our industry partner, Mr. Kunal, founder of Exact Next Gen Technologies, and all the tags, t-shirts, pants, or registration kits. It's all sponsored by Exact. So thank you, Mr. Kunal sir, for sponsoring all these goodies for our students. Thanks to our communication partners. So we connected with these conference, Cyprus, and STM journals. Thank all the publishing partners. We also thank all the professional society, IEEE PES, IAS, VTS, and also IEM. I extend my heartfelt appreciation to the faculty coordinators and the organizing members. Faculty members of my department, all the supporting and non-teaching staff who work tirelessly behind the scene, and student volunteers, the ADB team, account section, facility team. I thank each and every one for this successful conduction of ICASPS 2025. We also thank the present media. So before I conclude, I tend to announce the next series of this conference. So the next series of conference, ICISPS 2026, will be launching soon. So I expect everyone to contribute and participate in ICISPS 2026 also. So please mark your calendar for we shall meet again to further share our mission. If there is anyone I may have unintentionally missed, so I thank each and everyone for coordinating this event. And please know that every effort, big or small, has contributed immensely to the success of this conference. So with this, I conclude my word of thanks. So thank you all. Jai Hind.
With this, we come to the end of the validatory session of the ISP 2025. On behalf of the organizing committee, I thank all the dignitaries, speakers, participants, faculty members, and volunteers for making this conference a grand success. Thank you all. Have a pleasant evening. Request all the faculties to kindly gather on the dais for a group picture. Followed by the non-teaching staff. I request the student volunteers to kindly stay back after the event.
I told you to come back.
It's there. Live stream's not happening.
Hey, come back here. Come back. First. इधर करो. कुछ नहीं.
It's coming back.
Battery.
Request all the presenters to kindly gather on the dais. Presenters and the participants for a group picture.
Jeevan, I mean, want to take photo.
What a good thing.
I took.
What video?
I request all the participants and presenters of the conference to come on the dais for the photo session.
Oh my god!
I request all the participants to come on the dais for the photo session.
Extend it even faster. I was designing another project.
More digestive.
Requesting the volunteers to be recognized.
For some discount, the print that is like 20 grams. I need to get a scanner. I think it is. Yeah, I'll take this.
Come over, fit this side also. From there,
You can see there.
That's it.
Side.
Actually, passing around.
Hey, I can't. My battery is over. Varshini. Battery is over. Varshini. Varshini.
Endale.